fuck is Mario Judah?
Every rock star. I'm Mr. Rage. 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 I miss the things we had. I remember it all. I never said that I was sad. I remember it all. I miss the things we had. I remember it all.
I miss it.
I never said that
I miss the rage.
I remember it all.
I miss the rage. I miss the rage. I miss the rage. I miss the rage. Woo! I miss the rage. I miss the rage. Whoa! I miss the rage. I miss the rage.
I need love and you gave it to me.
All right, guys. What are we doing? What are we doing? Whoops.
Make me too
What are we doing? Guess what? Guess what we're doing? Oh shit! No way! I know you do not see what is in the bottom of my screen. Look at this. Whoa. Unfortunately, I'm gonna have to pull this to the side, okay? Technically, we can't be looking at this stuff that I'm gonna have pulled on the other screen, okay? So, what's going on? What's going on today? What's going on? What's going on? Guess what's going on, okay? We're probably pulling an all-nighter, okay? We're probably gonna pull an all-nighter because I need to get through this. I still haven't gone through... What the fuck? What the fuck? Peter, what are you doing? Crack. What the fuck? Yeah, okay. So I need to get through this whole skedaddle. Okay, I still haven't gotten through it. I still have, you know, A, B, and C to do. Okay. But thank God I got through this. Okay, I did this, luckily. Can erase this. So what's going on? You know what? I probably won't even be able to fucking get through this shit. The time-dependent There's gonna be a time-dependent Hamiltonian on here. I should just do this. I should just do it. I should just do it. I should just do it. And you know what? I'm gonna do it. But, okay, I haven't even explained the premise of this all yet. Now, listen, I haven't even explained the premise of any of this yet. Okay? The premise of all of this is that... Listen, okay? Hold on, let me just freaking... Okay. Okay. Basically, let's full cam this. Okay. Basically, what is happening? What you might be asking. Now you might be asking yourself, Paul, why are you doing an all-nighter? I don't think that's really necessary. Well, an all-nighter is actually might not be necessary, but more realistically, I'm probably only going to get like 4 hours of sleep tonight, something like that. But what's going on, right, is I have a exam tomorrow for quantum mechanics. I have not studied at all because I had 2 other exams this week. One today and one that was on Tuesday that I did. Got them out of the way. I thought that I could leave the studying for this class, quantum mechanics, a little bit later. I was wrong. I was sorely mistaken. I'm way behind on studying. So, either I stop studying now, I take the exam tomorrow, and I fail, or I sleep deprive myself to try to at least do a little bit of something, take the exam tomorrow pretty tired, and still fail. So, in both cases, I fail. However, there's a universe where I fail a little bit less. I've pretty much accepted my fate at this point, and that is, what is my fate, you might be asking? What is your fate, sire? Well, my fate, which you might, you're not asking, because okay. My fate is that I will just have to lock in for the final for this class, which, let's see what that grade bin is for the final exam. Let's see what their grade bin is for this. Let's see what the grade bin is. Womp womp. The final could be worth up to 45%. So the first two midterms could be worth 15%. Final could be worth 45%. Okay. So 45%. That's pretty big. That's pretty mondo big. Okay. But yeah. Fuck. But the final is going to be so much harder. It's going to be 3 hours, dude. Whatever. It's getting kind of hot in here. Is it just me? Is it hot in here or is it just me? It's getting kind of hot in here. What did I eat that has my stomach? My stomach's all fucked up. I don't know what I ate. Is it bananas? Yeah, these bananas are probably not quite ripe yet. But whatever. Anyways. Guys, this is what we're doing, okay? This is what we're doing. Okay, the main star of the show is whatever's on our iPad. So I'm going to maximize this more. Put it over here. All right, guys, this is the main star of the show. I need some grind music. Like this. Put on a little something like this. Mm-hmm. Okay, guys, what are we doing? What are we doing? What are we doing? Should I have this music? I don't know. Whatever. I'm also probably sick. I'm probably sick. Okay, is that what you wanted to hear? I'm probably sick as well. Okay. So, everything's not boding well for me right now, okay? I need some Joey.
Hello, Moto.
I need some Joey. I need some Joey in my life. Okay. This is what I need. Sip red till my lips red. Cauterize my cup, it looks like my drink bled. Oh my god, his lyrics are so good. Feel like him whenever I break bread. Okay, we're not gonna listen to Joey. We're just gonna listen to some electronic music. Where is my playlist? Okay. We're now locked and loaded, okay? Yeah. Okay, so we just did this. This problem is so much fucking worse. Well, it's so much easier than it seems, but it takes so much to like actually figure out what the fuck to do. This problem was so fucking because they don't tell you what to substitute lambda for, so you kind of have to figure it out. But but it's not obvious. It's like, should I substitute lambda for like 1/2 m omega squared? But then the derivative here becomes really complicated, right? So we need some derivative that's like easy to cancel out in the energy. So basically you just choose lambda equals omega and then you do a whole bunch of like fucking flipping it around. Okay, variable changes, whatever. Most of these problems aren't like hard. They're just so fucking annoying to figure out. I messaged a friend. I was like, hey, can you provide some help? I'm trying to double check my answers. I don't know if I'm on the right path at all. I feel like I'm just doing everything wrong. And they were like, yeah, sure, I'll send it over. And they haven't sent it over. It's been fucking 7 hours. It's been 7 hours since then. I'm hoping they send it very late. I'm hoping. Hold on. Da, 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 da. Okay. Messaging over. Not quite. Okay. Messaging for real over. Let's hydrate. Oh my god. Okay. I need to hydrate as well. I need to continually hydrate. Also, listen, usually I don't like turning on this light because it makes me stay up, but bright white lights. Okay, we need the most uncomfortable lights going on right now. Okay, fuck eye strain and, well, fuck not having our eyes be strained and comfortability. I'm gonna disable Flux, this little app that I have that makes the screen go yellow. So it's easier on the eyes. I'm going to disable that. Boom, it's been disabled. Okay, now we're looking at this problem, right? Time-dependent Hamiltonian for a two-state system. I have no fucking clue how to do time-dependent perturbation theory. But. Yes, I'm stable. Yes, I'm mentally stable. Of course I am. What would have made you thought that I wasn't? I don't know. I don't know. Okay. Whatever. There's a fucking formula sheet. Where the... I just gotta download this formula sheet, I guess. Let me just download the formula sheet. Occasional muting of the mic because my stomach is not doing well right now. I don't know what the fuck I ate, but it's just not. Okay, equation sheet is right here. Where the fuck is that formula? Okay, this is it. The transition amplitude. Okay. Okay, consider an electron placed in a constant magnetic field B equals B naught 0. The Hamiltonian of such a system is this. All right, that's the Hamiltonian. You can do the laser pointer. It's that. This is a polyspin matrix. The spin state is pointing up along the z-axis at t equals 0. I feel like this writes so much better than this. Okay, that's me writing hello with this. Like, just look at how much smoother this one is, man. So much smoother than this. This one like has some like fucking delay. I don't know. Ooh, dark mode's been turned on. Do you know what that means? Well, you know what that means. Okay, at first the spin of the state is pointing up. At t equals 0, a small perturbation is turned on. The magnetic field is turned on the magnetic field, acquiring a component along the x-axis. So this component, where B naught is greater than B naught, and omega are constraints. We can treat this modification as a perturbation to the Hamiltonian. This? What is the probability that a t is greater than 0? The state is found in a spin-up configuration. So, probability. What is the probability, dude? What the fuck? We know that CMA of T. This. Right, so the probability squared. It's going to get rid of this, so it's going to be 1 over h bar. Integral of h m a t squared dt. Right? Because it's going to get rid of our fucking motherfucking shit. Trying to see what the fuck to do with this problem. You know what? There's some lecture notes that I did not download yet either. This guy he fucked us up, dude. Can he just admit that he fucked us up? I'm getting so mad. I know I'm getting mad. Okay, listen. I have a right to be a little bit mad. Can he just admit that he fucked us up? Okay. He didn't post homework solutions until like fucking Wednesday. He didn't post lecture notes until fucking Monday. I have 3 other midterms, bro. I mean, 2 other midterms. Like, I can't just... I have to prepare for this shit in advance, dude. I can't just... Oh, it's okay, it's okay, it's okay. I'm being a bitch right now. Not in a gendered way. That's just what I am being right now, okay? I'm being a complainer. I'm complaining a little bit too much. I need to not do that. Okay, what the fuck are these notes, man? Time-dependent Hamiltonian! Time-dependent Hamiltonian! What? Was that even? Yeah, time-dependent Hamiltonian. Man, fuck this shit, dude. Okay, like, okay, I definitely have to finish this. And then after this, I have to review the homeworks. And I think that's pretty much all I can prepare for. That's all I can do, man. Like, that's all I can do. That's all I can do on my end. Like, that's it. What the fuck? What the fuck? Hold on. Okay, I just don't know. I don't know how to do this. How do you do this? Okay, it's time to watch a video. On time-dependent perturbation theory.
Yay, it's working. Okay.
Because I just don't get it.
Okay, folks. So the plan for today is to discuss time-dependent perturbation theory.
Mm-hmm.
All right. Did you hear that okay? Is everything good? Thumbs up? Okay. So, all right. So that's the plan for today. And this is a new topic, and it's a big new topic. It's a very important, big new topic. And so basically, we want to look to see how things change with time. And you've already done that in quantum mechanics. I just want to remind you, you have already been thinking about time, at least last semester you thought about it. And so I just want to remind you that you guys remember that if I have, you know, that we have some Hamiltonian, and we have some Hamiltonian that acts on these eigenstates, then you guys know that if my wave function at time t equals 0 if I know my wave function at time t equals 0, then you know that the wave function at some later time is equal to just a sum over all the eigenstates weighted by this weighting factor, where this is the wave function at time t equals 0, and then you have these time-dependent phase factors. Okay, so you guys all know this. Like if you already knew the wave function at time t equals 0, then you basically just expand into the eigenstates in this familiar way. So this I'm hoping that this is looking kind of familiar to you. And then you derive this. Remember last time you derived this last semester from the time-dependent Schrodinger equation, the time-dependent Schrodinger equation. And I'll remind you of that. It's just this: h psi equals I h bar d dt psi. And then from this you derive this expression using our old friend separation of variables. And in this case, the variables were position and time. Okay, so I'm just reminding you that. So this is what you've done. This is what you know or should know, or it should look familiar. Maybe you should go and review it if it doesn't look familiar. But here's the thing. What if separation of variables doesn't work? And it doesn't always work. In other words, when you did this derivation, then you assumed here that the Hamiltonian does not equal a function of time. And you might not even remember that when you did the derivation. I mean, you probably don't, because it's like last year sometime. But that's what you did. To do this step from here to here, you assume that the Hamiltonian is not depending on time, that's constant. And then you can do your separation of variables trick. But it turns out that separation of variables often does not work. We often have that the Hamiltonian depends on time. And then the trick doesn't work. Separation of variables doesn't work. And so your simple intuition in the semester goes into the garbage can. So if the Hamiltonian is time dependent, then simple picture falls apart. And I just want to emphasize that the simple picture doesn't always work if the Hamiltonian is not constant. And this is very common. So the h equals a function of time all the time, because the world is not static. I'll just write that. Our world is not static, and so that things change all the time. And so the idea that the Hamiltonian is a constant is pretty stupid. So, come on, give me a break. Of course it's not a constant. But we make it a constant because it simplifies the picture, and it's an approximation. We often say that h equals constant because it's a good approximation. But that in the real world things are changing all the time, and so we need to deal with that. So let's give an example. Example of a Hamiltonian where the Hamiltonian is changing with time. And there's many examples, many famous examples, but let's give one that you've seen before and that you think you understand, or you understand a little bit. Let's consider this example. Let's take an atom, and it has energy levels, like a hydrogen atom. Okay, that's why I draw an atom, just like a little box, and it has these levels: E1, E2, E3, etc. And then more levels up here, and then these have states associated with them. The eigenstates phi1, phi2, phi3. Okay, so those are the eigenenergies and eigenstates of some random atom. Now suppose that the electron in that atom is sitting here in the ground state. Now I shine a light on it. There's a little man. The little man has a laser or a flashlight, and he's shining light. He's wearing a hat. Who knows? And he's shining light onto the atom. And this happens all the time. I mean, anyone who's used a flashlight has done this, right? And so suppose that h bar omega is equal to E2 minus E1. Then somebody tell me what happens.
It transitions up to the E2 level?
Yeah, exactly. Then transitions up to E2. Yeah, that's exactly right. But here, now I'll ask you a question. What's the probability that happens? Suppose the little man has a flashlight with a certain strength of light, and he shines a light for, 72.6 microseconds. What is the probability that the atom will transition into that upper state? Now, can anybody answer that question? And of course, the answer is no, unless you've already taken this class. It's a trick question. So, you're not supposed to be able to answer that question. That's the whole point. That's what after this class, you should be able to answer that. After this course, you should be able to answer that question. But I want you to understand that, you guys have seen this. You guys have seen this before, in some other class. But the question becomes like, how does it happen? How does this work? Why does it happen? Why does it happen? And I know that you guys have never really stopped to think about it, probably because it's like a simple picture. Okay, I got that energy and it jumps up there, but really, why does it happen? And it's not completely obvious, because if you look at it, you remember that phi1 is an eigenstate, meaning that h phi1 is equal to E1 phi1, and that means that phi1 should be a stationary state. And stationary means unchanging. And so phi1 is a stationary state. That means it does not change in time, other than just a phase factor, the phase that's spinning. But it should not really change in time. And yet it does. When I shine light on it, I get a transition. And so already you can see, something's happening. Something funny is happening. And so that's what we want to understand. What happens. And so basically, what's happening is that the flashlight. What's happening is that the laser is changing h to a time-dependent Hamiltonian. So before the laser, then I had h equals a constant. What was a Hamiltonian before the laser turns on? Somebody tell me.
It was just the particle in a box, Hamiltonian.
Right, which is the nucleus. You know, it was just the proton, the nucleus pulling the electron towards it, the Coulomb potential. That's right, which I call a box. That's right. But after the laser turns on, while the laser's on, maybe I shouldn't say after. I should say during the time of the laser, I have that the h is equal to a function of time, because the laser, you know, is a function, the electric field is a function of time, and that makes sense because, you know, if this is a laser and it's sending out a light wave, then you guys know what a light wave is. Is that a light wave is this? You know, here's my atom, you know, with my energy levels, and then but the light wave is this thing where I have what is a light wave? A light wave is this. I have an electric field here, and here, and here, and here, and I also have a magnetic field B, and here it's pointing into the board B, and here it's coming at you. Okay, so this is a light wave, right? So a light wave is this traveling electromagnetic wave, and so you can see that the electric field, you know, there's an electric field that hits this atom, and the electric field is going to be a function of time. There's also a B field too, because an electromagnetic wave is this electric field and B field that travels through space, and when it hits that atom, the atom is going to see an electric field that very rapidly goes up and down and up and down.
Makes sense.
Okay, and so obviously this is going to cause my Hamiltonian to change in time. There's no tricks here, you know, it's just common sense. If the electric field, you know, the atom used to be just sitting there all stationary and unchanging, but then this electric field is going up and down and up and down, and so on. So clearly something, you know, the Hamiltonian is changing with time. So then the question is, how do we understand it? If the Hamiltonian is changing with time, then how do we calculate probabilities anymore? How do we do quantum mechanics basically? How do we calculate probabilities? Because everything kind of falls apart. All of the approximations that you made previously all fall apart, and so it's not obvious how to do it. You know, the answer is not obvious. I think, to me at least. I mean, unless you're some kind of genius. But for most people, the answer is not obvious. But it turns out, even though the answer is not obvious, the answer is simple. I mean, simple things are not always obvious, but that doesn't stop them from being simple. The answer is simple. You just solve the Schrodinger equation, like everything else. You just solve the Schrodinger equation, and the Schrodinger equation is this. Before you had h psi equals IH bar dtt psi, and the thing is, this still works. It still works when h is a function of time. Okay, so the idea is, I just want to say right up front, the Schrodinger equation still works. Thank God, otherwise we wouldn't know what to do. It still works, and so this is the Schrodinger equation now. Now we have h of t times psi of xt is x. I'm going to write it somewhere else. Too much there. We have h of t times psi of xt is equal to IH bar d dt psi of xt. Okay, so this is what we have to solve. And if you solve that, then everything works, and you can figure everything out. Okay, you can figure everything out, because what you would say is you would have boundary conditions. You might say that my atom at t equals 0 is in some eigenstate. Okay, that's an eigenstate. And then I might say my Hamiltonian at t for, then I might say that you could say for t less than 0, then my Hamiltonian is constant, h naught, and I could say for t greater than 0, I turn on my Hamiltonian is now time dependent. Okay, so that's what you do, and then you have boundary conditions, and then so then what you do is you solve. In physics, we know what to do. If someone gives you a big ugly differential equation, you know that you solve the differential equation, and you plug in the boundary conditions, and then you just get the answer. So that's sort of a general prescription, and that works. But the problem is that it's too hard. Just plugging into this differential equation, the time-dependent Schrodinger equation, and then just grinding through the differential equation, and then plugging the boundary conditions and doing it exactly. It's just too hard. It's like, you know, it's this big nightmare. I mean, people do it, of course. You know, web computers and theorists, and, you know, spend their lives doing it. But for most people, it's just too hard. It's just a big, complicated mess. And so we want to know, how do we think about it? You know, how can we understand it in an intuitive way, and how can we boil it down to just some very simple recipes, some simple formulas and recipes that allow us to solve physics problems without too much difficulty.
Dude, what he said just there, every single fucking physics professor should do that too.
Everyone's lazy, and nobody wants to work harder than they have to. I know I am.
God.
So nobody wants to do more than they have to. And so what we do is, to make it simpler, is we use perturbation theory. And you can already see how. So we use perturbation theory, and you can already see how the perturbation theory might rear its ugly head, because the idea is, if at t less than 0, my Hamiltonian is some simple Hamiltonian, like let's say a hydrogen atom, then if I turn on my laser, I shine light on it, turn on the laser at t greater at t. If I turn my laser at t equals 0, then for t greater than 0, what we would say is h is equal to h naught plus the Hamiltonian, the change, the new Hamiltonian, the perturbation, which is due to the laser. So that's the perturbation due to the laser. And so you can see how we can formulate time-dependent problems in this framework of perturbation theory. I just sort of want you to see that there's a very natural framework, and you guys have already had experience with this perturbation theory, and so you can already kind of get a sense of where we're going to go with this. We're going to start with our unperturbed states, and then we're going to turn on the perturbation. Okay, and that's how we're going to understand how things change in time. That's how everybody understands it. That's how like normal people use quantum mechanics all the time. You know, when you're thinking, okay, how do I understand these time-dependent processes? Because there's no real stationary states anymore. And how do I understand it? Oh my God, it's so hard. It's just a big nightmare. But what we do is we think in our brains in terms of perturbation theory. And so perturbation, and before when I told you about perturbation theory, I said this to you before. I don't know if you completely appreciate it, but one of the points of perturbation theory is that perturbation theory, first and foremost, is a way to calculate things. We calculate stuff with perturbation theory. We've already done that. You just have the midterm and you got to calculate all this stuff using perturbation theory. So you understand that. But second, and very important, is that perturbation theory gives us an intellectual framework to understand how nature works. Because just most of us are unable to solve the Schrodinger equation in our head. It's this differential equation, and most of us are not smart enough to just solve it in our head for every situation. And so we need simple frameworks because we're just simple humans. We're just animals. Our brains are not too big, and so we need things to be a little simpler. And so perturbation provides us with a simpler picture that we can sort of understand things. It provides us with a physical picture, and I want you to appreciate that. That perturbation theory is not just a calculational technique, but it's a whole framework for visualizing how quantum mechanics works. So let's think about it for a second. Like here, for example, let me just kind of give you a sense of what I'm talking about. I mean, so if before the laser's turned on, before laser, I have my atom is just sitting in some eigenstates, with their energies, and it's happily sitting in an eigenstate. Then what happens after I shine my laser? Then there's some probability that I have a transition. I go from this state to this state, and this is my phi 1, E1, phi 2, E2, phi 3, E3. Now, that's sort of how we think about it. You were even taught this picture, but I want you to appreciate that what you were thinking and what you were taught is already perturbation theory, because the way we visualize it in our minds, we have these are the unperturbed states, and we go from one unperturbed state and we transition to a second unperturbed state. So this is a transition, from here to here. That's a transition. So you see how the light that hits the atom is causing a transition from one unperturbed state to the other. So that to even consider that the electron is jumping from one state to the other, the states that we're talking about are the unperturbed states. But you have to understand that this picture is already using perturbation theory, because in reality, the unperturbed state, there are no unperturbed states. When the laser is turned on and the electric field is hitting the atom, the old Hamiltonian is gone. I have a new Hamiltonian, and so these states are no longer eigenstates. So when you even think of transition from one state to another, you're thinking in your head, I'm going from one eigenstate to another, but those states are no longer eigenstates when the laser is on. And so really that picture to say that the electron is transitioning from one state to another, that we're already using the perturbation theory, because we're using approximations. We're basically saying, well, the laser's on, and so those old atomic states, they really aren't eigenstates anymore. The new atomic states are some really incredibly complex states, and I'm really making transitions between the new eigenstates. But the new eigenstates are just this horrific complex mess that I can't even understand how to visualize. And so I'll just discard all of that complexity, and I'll just think in terms of the old states. And that's sort of using perturbation theory already. And that's what we do. But I do want you to appreciate that what's really happening is that when what's really happening is that the light is causing the old states. What's really happening is that you're sitting in some old states, and then you have the light, you turn on the light, and then you get some new states. I'll call them phi 1 twiddle, phi 2 twiddle, phi 3 twiddle. And so these are the new eigenstates. And these are the new eigenstates that solve the new Schrodinger equation, when h is equal to h of t. And what's really happening is that you're making transitions. What's really happening is that you have your wave function can be written as some linear superposition of the new eigenstates, where I have the new phi n twiddle, and you have your original eigenstate here, which is psi at x t equals 0. And so you have to overlap that onto the new eigenstates, and they are evolving in time according to their new energies. And so this old idea still works, but you're evolving in time because you're no longer in a true eigenstate anymore. You're in a bad mixture. And so this causes you to have, that's what causes transitions. The fact that you're no longer, that your old state used to be an eigenstate, used to be a stationary state, and is no longer stationary. Okay, so if that didn't make sense, then let's not worry about it, because we're gonna go through the prescription. I just want to give you some kind of overview of that, but we're gonna go through the prescription very in great detail. And so the question then is, so let's so far this has been an abstract discussion, but let's make it more like let's consider the most important example. The most important example of time-dependent of this phenomena is light. So I'm going to use the idea of shining light on an atom as the problem that we want to understand the most for time-dependent processes. And but this could really apply to any process. It doesn't have to be light. I'm just using this as a concrete example of a time-dependent quantum mechanical process. But it really could be anything. I could turn on gravity. I could turn on some 3 or 4. So I could do, there are other things that we can do. Okay, but so let's solve it. Let's solve this problem. This is the problem that I want us to solve. I'm sitting in some state at t less than 0, and I'm sitting in some state. I'll call it the kth state, some random state, and I shine and then I shine some light on it at t equals 0. Turn on laser, and then at t greater than 0, I want to know what's the probability that I have made a transition to some other random state. At t greater than 0, what is probability to be in state M? So we start in state K. Okay, this is the problem I want us to solve. So this is a well-defined quantum mechanics problem. We started in state K at t less than 0. At t equals 0, I turn on the laser, which has some frequency h bar omega, some electric field that's oscillating in time with frequency omega. It hits the atom at t equals 0, and at some time later, and let's say I left the laser on. So let's leave the laser on. Laser stays on. Then the question is, at some later time, what's the probability that I find my system transitioned to some new state? All right, so that's a well-defined problem.
Professor.
Yeah.
So in reality, when the light is shined on the particle and it transitions, it's not going to be another eigenstate, but we're treating it as it is another.
Yeah. Because the other states are no longer true eigenstates. Because what is an eigenstate? An eigenstate is this. H psi equals E psi, right? That's an eigenstate.
Yeah, and then
this goes out the window, right?
Yeah. Okay, got it.
That's right. And so but we're going to pretend that we're going to pretend that the eigenstates still have meaning. And they do have meaning. They do, because it's sort of like that's like what you've done up to now. We've been talking about perturbation theory. We've been talking about the unperturbed states and the perturbation, and what's the energy now, how the energy shift and this and that. But we're doing everything. We're using the unperturbed states as like our framework, and the reason is because we understand the unperturbed states. They make sense to us, and so we need to grab onto that like a safety jacket. Like we're drowning and we need to grab onto something to stop us from drowning. So we grab onto those unperturbed states. And that's it's not just a psychological prop. I mean, it really is, even physically. As long as the perturbation is weak and short, the unperturbed states are still mostly okay. All right, and that will make more sense as time goes on. Okay. All right. So we got to solve this problem. And so how do we do it? Then, what do we do? What do we do? How do you solve this problem? All right. It's not obvious at all. It's simple, but not obvious. Different things. So, okay. So basically what we have to do is we have to solve this. Basically just solve the Schrödinger equation. H psi is equal to I H bar d dt psi. All right. That's the Schrödinger equation. So that's what we got to do. And it's not, so that still works. And so, but the problem is that now H is a function of time. So we have to solve this problem, which is kind of a pretty hard problem. Okay, so that's what we got to do. And so the question then becomes, how do we do that? So, well, what's the first thing we got to do? Somebody tell me. This is what we got to solve, okay?
Assume psi is separable in x and t.
That is a smart thing to try. That's the separation of variables, and that's what you did last semester to solve this problem. But that only works when H is constant. So that's not going to work now. At least it's not going to work. We can't use separation of variables as easily as we did before. Well, we will sort of use it. But what's another thing that we should? But we'll do something like that. But before we even solve this equation, do we know all the terms in this equation? What is it that we're missing?
The Hamiltonian?
Yeah. So let's start with the Hamiltonian, and then we can start making assumptions on the structure of the wave function. So we will do something like what you said, like separation of variables. So the first thing a good place to start is the Hamiltonian. And so I could just leave this as a completely we can just leave it as a completely abstract Hamiltonian. We could just say, H equals H of t, just some arbitrary time-dependent Hamiltonian. But I want it to be a little bit more tangible than that. Let's actually calculate what the time-dependent Hamiltonian is. And so for light, so if we're shining light on something, then here's my light wave hitting something, hitting an atom. There's an atom, with its energy levels. And then the question is, what is the Hamiltonian for that? And so it turns out that the right way to do it, it's kind of complicated because we have an electric field and a B field that are changing in time. They have a time dependence to them. And so basically, this is the right way to do it, and then I'll make a big approximation. So the correct way is to use the vector potential A, which is related to the electric field and B field, because you guys remember that the B field is equal to the curl of A, and the electric field is equal to the time rate of change of A minus the gradient in phi. We also can have this. And so if we have a vector potential, then what we can do is we can say that the Hamiltonian for an electromagnetic field, which is a function of time, can be written like this. We have the momentum minus a charge. If there's a charged particle in here, like an electron, we have the charge of the electron times the vector potential squared over 2m plus q times phi plus, well, we'll just stop there. Okay, so this is the Hamiltonian for an electromagnetic field, for a charged particle in an electromagnetic field. And so often in quantum mechanics problems, you will see the vector potential. The vector potential plays a big role in quantum mechanics. A equals vector potential. So I just want to say that, because it's true. The vector potential is really important. It's a really funny thing that when you learn electricity and magnetism, the vector potential is there, but it's sort of not that important really compared to the actual scalar potential. And you don't use it all that much, but in quantum mechanics we use it all the time because the vector potential is sitting right there in the Hamiltonian. Okay, so to really do electricity and magnetism correctly in EM we need the vector potential. But for today this is too hard, and so we want to do it easier because 99% of the time we only need the electric field. Okay, and so I just want to say that, like, for an electromagnetic wave, it has an E field and a B field, and changing in time in this complicated way. And to do everything correctly, you have to use the vector potential. But for most of the time, we can get away with a much simpler formulation. So the simpler formulation works 99% of the time. And so this is what we'll do in this class. The simpler formulation is that we have we know that if I have if we know that if I have an E field, an electromagnetic wave has an E field that's coming in, and I know that and I have my atom. And I have my charged particle, the electron, which is sitting in that atom, and the charged particle feels the electric field. And we know that what it feels is a force. And this is a classical discussion. Remember, we always use classical mechanics to get the Hamiltonian. That's you always start with classical mechanics. And so we know that there's a force that charge feels, which is Q times E. And we know that force is equal to a gradient in some potential. I'll call it U, or I could call it V. I'll call it U. And so then we know then that U is then going to be equal to the negative of the integral, because I can, I can integrate both sides. So integrate both sides, and then we get that U is equal to negative Q E dot dr from 0 to do all these things correctly. So then this would be U of R. Okay, so this you've done before in some class. I know you've done this before. So if I have some force, then I just can integrate both sides to get the potential and have that little negative sign, which is so annoying, makes everything look more complicated. That's not so bad. And so then you see that then what we can do is we can just say let's just say that if E is constant. Here's the thing. An atom is small. Atom is small, and so if the wavelength of the light is giant, that's the wavelength of the light. But if the atom is tiny, there's my tiny atom with its energy levels, then over the distance of the atom, the size, delta x of the atom, then I can say that the E field is constant in space. It's not constant in time, but it's constant in space. Do you see that? For small things, or small atoms. Can somebody tell me, to justify this approximation, can somebody tell me what is the wavelength of optical light?
400?
Like 600 nanometers or something?
That's right. Let's say 500. So lambda equals 500 nanometers. That's 5,000 angstroms for let's say green light. And what is the size of an atom?
An angstrom.
Exactly. 1 angstrom. So this approximation is quite good. All right. For most things, this approximation is great. So that means that if the electric field is constant in space, then that means that I have U of R is equal to this integral. But when I integrate it in space, then it's just going to be Q E dot R. So simple. All right. And so that's our Hamiltonian. So this is really, isn't that easier than all those vector potentials and stuff? So it's so simple. And so then we have for light. Well, so for light we have that the electric field is equal to some E naught. For a real electromagnetic wave, it looks like this, sine of K dot R minus omega T. That's an actual electromagnetic wave. Okay, that's a wave, an EM wave. But what we're assuming is that that's a general electromagnetic wave, plane wave. But if the atom is small, then what the atom sees, if the atom is small, then let's assume that the atom exists. Let's assume that the atom sits at R equals 0, and so then what we have is that E equals E naught sine omega T. And I'm just going to ignore that little negative sign in the argument there, because I could just start my time at a different time to set the phase. So this is my electric field of the electromagnetic wave, and so then my perturbation Hamiltonian is going to be E naught sine omega T times Q dotted with R. So H prime of T is equal to Q E naught dot R sine omega T. Okay, so this is a very typical time-dependent Hamiltonian. So that's the time-dependent Hamiltonian that my atom sees when I turn on a laser. So this is coming out of the laser. Coming out of laser. I just want you to understand that. I mean, like, you turn on your laser, and so this is what you're doing to the atom. The atom is like, oh, I'm feeling this H prime. Okay, so that's what's happening. I just want that to be clear. Okay, and so now the question is, now let's go back to this original question. So I'm sitting, my electron is sitting happily in some random level. It's a stationary state at time t less than 0. Then at time t equals 0, I hit it with my laser, and then some later time, t greater than 0, I want to know where it is. I want to know what's the probability that it has transitioned from phi k to some new state, phi m. So what's the probability? Okay, so this is the problem that we're trying to solve. And so what we can do then is we'll do this. We'll assume that at t less than 0, then we have the Hamiltonian equals h naught, and we know all the of your, and so the and it's like you can think of it as physical. So let's say that this guy has a big probability, a little probability. This is really important. I want, because you have to ask yourself, what does a transition even mean? This thing Cn of t, because this is the way you have to picture it in your mind. I have levels. These are the levels of phi 1, phi 2, phi 3, phi 4. These are the unperturbed states. And the way to think about it is that there's probability. There's a probability to be inside of each state, probability. And so the probability here is C1 squared, C2 squared, C3 squared, C4 squared, etc. And in the old way, these numbers were constants. And so even though the particle could have a probability to be in different states, those probabilities never changed in time. And so that means that there were no transitions previously. But now what we have is that these are functions of time. And so basically what's happening, so this is really important. I want you to think of this is probability. And so you can think of this probability as a conserved quantity. So think of the probability as a conserved quantity. And that's true because we know that the integral of the probability is equal to what? What's the integral of probability?
1.
That's right. Or I could say, the sum over n, the probability to be in En is also 1. Probability is conserved. There's a finite amount of it. And so when I write the wave function in this way, with these coefficients in front of the eigenstates, those coefficients squared give me the probability to be in each of those eigenstates. And so you have to think of this as like stuff. There's some stuff. And it's like, you can think of it as physical. So let's say that this guy has a big probability, a little probability, smaller. I want you to think of this as stuff, because I think this will help you to visualize what's happening. That there's this finite probability, and you can think of it as a fluid. I think it's most useful to think of this as a probability fluid that can slosh around. And in the absence of a time-dependent perturbation, the probability is fixed. But when I turn on the time-dependent perturbation, the probability can ooze around. Probability can go from one level to another. And so a transition, when we're talking about a transition from say state phi 1 to state phi 2, then what that means is I have a lot of probability here at t equals 0, but then at some later time, phi 1, phi 2, some of that probability has shifted. The probability has moved. So the probability, think of the probability as flowing. The probability flows. And so what we want to do is so our job is to track the flow of probability. Track the flow of probability. And how do we track the flow of probability? By calculating, the way we do it is by calculating something. Let me remind you, the wave function, as a function of time, we're now writing it like this. C n of t, phi n of x, e to the negative I, e, n, t over h bar. How do we track the flow of probability? What do we have to calculate? What is the most important quantity?
Cn of t.
Yes. That's the most important thing, the Cn of t. Because the probability...
You just get the C factor and the base factor with the
Well, let's actually, maybe we should just even do it. I mean, it's like psi this. What is... And that is the probability. We just calculated it. That is the probability to be in state m at time t. So this is the most important thing. So this is what we want, okay? So I just want to emphasize that this is the most important thing. And so we write the wave function in this new way. So you've actually never seen this before, unless you've taken this class before. Making that coefficient a factor of time is actually this big new thing. But I want you to see that it's actually a very natural, very normal thing. There's nothing weird about it because it's just telling us the probability at time t to be in that state, the nth state. All right. So I just want to emphasize that this is a very natural way to write the wave function. Okay. But then the question becomes, can you guys hear me okay? Can you hear me?
Yeah, it's good now.
Okay. So, okay. So then how do we find that this is a very natural way to write the wave function? Okay. But then the question becomes, can you guys hear me okay? Can you hear me?
Yeah, it's good now.
Okay. So, okay. So then how do we calculate this probability, Cm of t? How do we calculate it? Okay. So we have this thing. We know that the wave function is equal to this sum, phi n of x, e to the negative I, t n t over h bar. Then but how do we calculate this thing? How do we get it? So can someone tell me what to do?
Don't you do that thing, which in the E&M Griffith's book, it's called like Griffith's trig or something like that?
I don't know. Oh, I think I know what you're talking about. No, yeah, no, there's something more that we have to do. Actually, that won't work now because the Cn of t is like, we don't know the functional form of the Cn of t. We don't know what it is. It's a function. It's a mystery function. Mystery function. How do we find this mystery function? It's not known. How do we calculate it? Can anyone guess?
Does it have to do with like the weight of the Cn at t equals 0?
Yes, it will. We will use that definitely. But still, that's a boundary condition. So that's good. You're totally right. That's a boundary condition. But when we solve a problem in physics, typically we solve a differential equation, and after solving the differential equation, we then plug in the boundary condition, which is what you just said. So now I'm asking, what is the differential equation?
Would we plug in that psi into the Schrodinger equation and find some formula for Cn? Okay.
Yes, that's correct. That's exactly what we do. Good. That's perfect. That's exactly right. We plug into the Schrodinger equation. You know, if someone asks you a question in quantum mechanics, if you answer, use the Schrodinger equation, if you just randomly say that, you'll probably be correct like 7 out of 10 times. So if in doubt, just say, use the Schrodinger equation. So if I ask you a question, just say, how about the Schrodinger equation? You'll probably be right, because, you know, it almost always is the Schrodinger equation. Okay, so let's plug this into the Schrodinger equation. So that's good. So here's the Schrodinger equation. The Schrodinger equation is h of t psi is equal to I h bar d dt psi. Let's plug into that formula. And so let's do it. So here it is. H is h naught plus h prime of t. And we know what h prime is. That's that electromagnetic wave thing I derived. So we know that. And now we got to plug in psi. And we know what psi is. It's n. It's c n of t phi n, which are functions of position, e to negative I e n t over h bar. And then this is equal to negative h bar over I d dt of n c n of t phi n of x e to negative I e n of t over h bar. Okay, so that's what we do. And so now we just have to grind through some algebra. And when we grind through the algebra, the nice thing is that when this h naught hits this en, what does h naught turn into?
E sub n.
Exactly. That's exactly right. And so let's just do some of this algebra. So we're going to get, when the h naught hits it, it's going to be a sum over n, and it's going to be en cn phi n e to negative I e n t over h bar. Then when the other guy hits it, it's going to be the sum over n h prime of t cn phi n. You tell me. I mean, look at this. The sum of, what do you call that? That mathematical quantity.
Is it a mixing factor?
Say again, what?
The mixing factor?
Yes, it is a mixing factor. That's correct. But it also is something else. It's like as a mathematical, like if you were in a linear algebra class, what would you call that? I mean, it has another name too. You're right.
The matrix element?
Yeah, that's what I wanted to hear. It's a matrix element. And it's the matrix element connecting Em, which is the most important thing. Because what we want to know is Pm of t, the probability to be in state m at time t, which is the square of Cm of t. And remember, this goes all the way back to this problem. You've probably already forgotten what we're even doing and why we're doing it. We're solving this problem, solving this. We have the atom at t less than 0, the electron is in one state. We turn on the laser at t equals 0, and then we want to know what's the probability to be in that state, phi m. And the probability is going to be this thing, Cm of t squared. So that's the problem we're trying to solve. And so now, look, we solved it. We did all the algebra, and we got it. We got this, but we got it sort of as a differential equation. So this equation that I now give 3 stars tells us how to solve it. But as you can, when you look at it, you realize it's actually a really hard equation to solve, because that's what we want. But notice it has the Cn's of t in it as well. So when you look at it, it looks like it might be impossible to solve. But actually, we can solve it by using approximations. Then what we need next is going to be some approximations, and that will allow us to solve it. And that is really the essence of perturbation theory, are going to be those approximations. So we'll do that next time. Bye-bye. See you later.
All right, dude. Oh, fuck. Okay, well, guess what? I wasn't listening to much of that. I was working on this. And I can't figure this out for the life of me. It's a 5-point question. I should be able to do this, as he said, in like a fucking hour. I don't know why the fuck I can't do this in an hour. At first, the spin in the state is pointing up along the z-axis, okay? So it acquires a component along the x-axis. And we treat it as a perturbation. And we're asking, what is the probability that is found in the spin up? How do I figure that out, dude? Hmm. Okay, I'm seeing some notes here. Okay. Seeing some notes here. Right? I'm going to walk you through what I'm seeing. Walk you through my thought process, okay? Seeing notes here. Right? So I need to find the probability that it is found in a spin up configuration. I can't do this shit, dude. I could do this if you give me time, but I don't have enough time. And that's just the case. Okay, enough moping around. Now that my moping has ended, okay, moping time over. Let's get back to this. What is the probability that at t greater than 0, the state is found in a spin up configuration? So we have something here. Consider a spin 1/2 particle in a B field pointing along the z-axis. Hamiltonian looks like that. At t equals 0, surely he talked about this in a lecture. Let's see. I'm going to have it on the other screen.
Looks like this. By 2i. Positive, right? Both of them are going to be lambda a n prime. The h bar took care of, right? Then this thing. But also on the negative side, right? 2 pi over t. A factor of h bar And so for this, we need to determine the overlap coefficients of the time-dependent states. Because at t equals 0, the state is at A. This means that so my top thing of list of things to do is 0, and then the time that we're looking at this potential, I'm just going to jump in. So we're looking at an example where the Hamiltonian looks like this. So it has a time-dependent part, and then the time-dependent part is just a step function, which is this guy. Okay. And so if we look at a particular matrix element, and these are matrices, so we look at a particular matrix element, say the A to A matrix element, then this guy basically is 0 below t equals 0, and then it jumps to this value, which is going to be this is equal to. The case where you had
No way it was covered in this one.
the state prepped in an eigenstate of the amplitude.
Oh, it was.
So we need a. This guy is going to be proportional. Yeah. Which is all I needed in that proof. Correct. Yeah. In general, you have this, constraint that the off-diagonal terms would be equal. You have like the whole term is equal to purely imaginary, and the come up with like, and this. So here's a very simple problem that I think it's the kind of thing that I should expect you to be able to do in an exam. So let's think about a two-spin system. So here I've been thinking about arbitrary, size Hamiltonians. These guys can be arbitrarily large. Let's think about a 2D Hamiltonian system. And so there's going to be two spins because I'm introducing a spin 1/2 particle. And we're going to put it in a B field, in a magnetic field. And at t equals 0, the magnetic field is just pointing along the z-axis. So at t equals 0, the Hamiltonian, which is always equal to the magnetic moment of the particle times the B field, just looks like minus 2 mu 0 times the B field, and then this is along the z-axis. This is going to be proportional. It's going to be along the z-axis, and this we can always write to be as 2 mu 0 times the spin of the particle, and the spin is equal to, in this case, z, which is going to be equal to h bar 1/2 sigma Pauli matrix. Sorry, I think I have a typo in my notes. This is going to drive me crazy because I already absorbed this into. Okay. This is going to lead me to a mess. Let me put it like this. Let's write it this way. And I'll absorb the h right here. I'm absorbing it into mu 0. Yeah, sorry. So this means that this is equal to mu 0 b 0, and then the z Pauli matrix is just this. Okay. This is a 2x2 matrix. And what we're going to do is that we're going to use a time-dependent correction to this. That is going to be lambda h prime 2 mu 0, which is going to be not only time dependent, but it's going to be pointing along the z-axis. So we're going to basically grab the field, and at some point in time, so the field is pointing along the z-axis, and then at some point in time, we're going to give it a modification that's going to be pointing along the x-axis. So this is the z-axis, this is the x-axis, this is the x-axis, this is the y-axis. And at some point in time, we're going to choose a component that points along this direction in such a way that the total magnetic field points along this direction. Okay, and that piece is going to be time dependent. And it's going to be relatively simple. It's going to be sigma x over 2, and the time dependence that we're going to pick is just two simple step functions. Where what we do is that what we're considering is a scenario where h prime of lambda goes from, this is time right here, so it's 0, right? The step function is 0 unless the argument is positive, right? And so, and t, capital T right here is a constant. Capital T is a constant that is greater than 0, okay? And so for negative t, both the arguments of the theta functions are negative, and so both of them are giving you 0. Then this one kicks in at t equals 0, right? And then at capital T, when little t is equal to capital T, this one kicks in, and you have 1 minus 1, which is equal to 0, so it turns off the potential. Okay? So it's a simple step function. And the height of this thing, right, well, it's going to be proportional to this, and it's going to depend on the direction of speed. Okay. So we need initial conditions. So in addition to all this, at t equals 0, we're just going to assume that the state is pointing up, the particle is pointing up. And so this means that the energy of the sky, right? This is in a two-dimensional spinor representation. This is equal to 1, 0, right? Well, the 0th order Hamiltonian is this guy, right? So this just gives me that this is equal to there was a minus sign. Nobody told me about this. This is equal to 2 mu naught b 0. I'll get back there. Eigenstate. In other words, it's just originally a state we prepped it so it's an eigenstate of the unperturbed Hamiltonian. Okay. And so the question is, we're trying to answer is, what is the probability? Probability that at some time greater than capital T, right? So we've introduced some perturbation into the system, right? So sometime here, this is capital T right here. All right, sometime here, that the system, my particle will be in a spin down configuration. Right? If I don't introduce this, right, the state is, is an eigenstate of the Hamiltonian is going to stay like that forever, right? But if I introduce a perturbation, then there's some probability that it will flip. And so if we use our handy dandy equations, right? Let me go back just to remind you what we wrote. I'm going to erase everything but the last line because we'll need the last line. The probability we derived last time is the probability of finding a particle in that is in A transitioning to M at some time T. This is equal to lambda squared, a squared squared, times the integral from 0 to T dt prime. I mean, it's just our coefficient. Let me just, I don't know why I'm writing all this mess. We already have it right here. It's just equal to this one coefficient, which we have there. Okay, so we need the matrix elements are the term Hamiltonian as well as the energy differences, right? Remember that AM is equal to WAM is equal to W minus WM. And these are frequencies, so this is energy minus the energy of M divided by A squared, right? In this specific case, yeah. In this one, sum over there's no sum. Because we to get here we assumed that the coefficients were I just wrote it here. We consider the case where you had the state prepped in an eigenstate of the Hamiltonian, which is exactly the scenario that we're considering. Yep. Consider that. Is that M. So this one coefficient. Have it raised from lambda squared. So the probability we derived last time is the probability of finding a particle in that is in A transitioning to M at some time T on this bit right here. Difference W frequency. Yeah. In this one, sum over there's no sum. Because we to get here we assumed that the coefficients were I just wrote it here. We consider the case where you had the state prepped in an eigenstate of the Hamiltonian, which is exactly the scenario that we're considering. So there's no sum. Yep.
Oh, dude, I forgot how to do fucking matrix math. What the fuck? It's row, column. Right? Oh my god, I can't believe I have to fucking refresh my memory on this.
In this video, 6 in columns. So, matrix B, when you're multiplying the number of, if they'll multiply a matrix sum of matrix B. So 3 first row by the second column. This result plus 2, and then of matrix B.
Row, column.
Base 6. 4 times row, the second B, 8, which. Now let's multiply the first row by the second column.
Okay, so it's row by column. So row by column. So 1 times 0 is 0. This will give me a 1 by 2. So 1 times 0 is 0. 0 times 1 is 0. And then 1 times 1 is 1. Plus 0 times 0 is 0. So it's going to be 0, 1. times 1, 0. So 0 times 1 is 0. So it's going to be 0. So this is 1 by 2, 2 by 1. So it's going to be 1 by 1. So it's just be 1. Okay. Okay. The fuck?
So two things we need. We need the matrix elements of our perturbed Hamiltonian as well as energy differences. Okay. We just looked at the energy of our up state. In fact, the energy of our down state with respect to our unperturbed Hamiltonian is straightforward, right? It's just a negative sign of the other guy. Right? So this is easy. Easy peasy. Okay. So we got most of the pieces, right? We need this, but that's just a difference of those two guys, which is twice the energy of just one of them. And then we need the matrix element of our perturbed Hamiltonian, right? And that part is also easy because Pauli matrices are easy to deal with. So I'll make sure I have everything. So we need the matrix element of this guy. For yep. Which is going to be just write it out. Write it out. It's I have the theta 1, 0, 1, and then acting on this is equal to 1. So it's equal to 0, 0. Make the 0, this 1, 0, and this 0, 1. You pick up this one. Okay, sounds good. So we got almost everything, and so this is great. So the down state, I factor the integral prime. And then have the faces as well. Or minus theta of t e to the I, the energy of minus the energy of the unperturbed integral. And so this part, right? So this minus this is equal to 2 times this because of what we have up there. And then this integral is relatively straightforward because this thing is equal to 1 in this region, but it's 0 everywhere else. And so I can just write this thing. So let me just make all this stuff lambda or alpha just so I don't have like a messy expression. So I have alpha from 0 to capital T, t prime, and then I have e to the minus, oh, this absolute value of this thing is switch. Yeah. Minus I, 2 times the energy of the spin up, system divided by h1 squared. So then this integral is just exponential, which even I can do. And then I have, now watch me screw it up. This is from 0 to capital T. Right, so I'll just drop the boundaries, right? I just fix this stuff equals to 1 within the region, 0 everywhere else, right? So that's equal to alpha, and I just evaluate the stuff in the boundaries. And at this point, you know, you're pretty much done. You can make this prettier, but you're basically done. You give me this expression, assuming it's right, I won't complain, okay? But you can always clean this up a little bit to make it a little more clear what's going on. And you can write the stuff that is in the parentheses, so probability up to down. I don't know why I took the mod squared of this. It's not mod squared. This, well, I'll have this alpha. Oh, stuff cancels out. Let me clean it up actually. So I have like lambda squared, and then I have lambda mu naught v naught over h bar. Right. And then the stuff in the bottom right is equal to 2 times. I'm missing a factor of 2 somewhere.
I think my original working was actually correct. Yeah, because now this is just going to be integral of cosine omega t. Fucking hell. Yes. Okay, so this would just be then. That's the probability. Probability in spin down is going to be the same, except replace this with 0, 1. Which I think would just also give the same thing. Except for the energy would be different. I'm trying to click a cell on the spreadsheet and it won't let me click it. Okay. Holy fuck. Holy fuck, dude. I was about to lose my fucking mind because I couldn't press a cell on the spreadsheet. Oh my god. I'm irritable. I'm irritable right now. I don't know if you could tell. Yeah, I'm pretty sure this step was superfluous, but superfluous? I don't know. Row by column. I'm already losing my mind. I'm already losing it. Row by column, so 0 times 0 is 0, 1 times 1 is 1, so it's 1. 0 times 1 is 0, 1 times 1 is 0, so it's 1, 0, 1, 0. 1, 0, so it's also 1, yes. Okay. It's pretty much the same thing, I think. Except now we have something like this. So we're actually going to have a factor in here that we have to care about. I believe. Unless we can somehow simplify this. I don't know. Feel like we should be able to combine this. So we know that e to the negative I. So what is it? Like e to the I theta plus e to the minus I theta is equal to 2 cosine theta, right? We know that. I don't know if that makes our lives any easier. Can we make any assumptions about the energy, dude? Wait, no, we can just keep it as omega. Can we not? Wait, let's just keep it as omega. Let's not do all this bullshit. Yeah, omega AM. Let's just make it omega. Omega down to up. Does this make our lives any easier? I don't actually know. Integral from 0 to t cosine wt times e to the minus I omega t over h dt. No, it did not make our lives any easier. What the fuck? What if I take that and then square it? Nope, didn't make it any easier. Yep. That's okay. Okay. I don't know how to do this. I guess that's okay. Now, recap time. Pretty sure I got all this correct, except for 2. And 1. Yeah, fuck it. Okay. Guess what now? We're done with this shit. We're done with this. I'm going to now just review the homeworks. Okay? I'm going to review the homeworks. That's what I'm going to do. Okay, fuck this shit. I'm done unplugging it. You can't see it anymore. That means I'm done. I'm officially done. Yeah. Okay. Hey guys, do you want to watch me change my water filter? Wouldn't that be interesting? Why don't we do that? I'm gonna go change my water filter. Not my water filter, but filter for my humidifier. That's what I meant to say. I'm gonna go do that. Watch me do that. That's pretty cool, isn't it? Isn't that cooler than whatever this is? I'll be back. Yes. That is my humidifier, ladies and gentlemen. Can you believe it? Alright, so check it out. We have our filter right here, right? So I gotta clean this. How am I gonna do that? You might be asking. Very easy. Very simple. Okay, we have simple ways. Let me turn up the gain. We have simple ways of solving our problems here. Okay, very simply, I have to clean the whole thing. So I think one of the reasons why I might be getting a little sick is because I need to replace this filter. I have no way of actually confirming that, but it can only help, right? Like, it only helps to replace this shit, right? So, let's open this up. I was thinking of going outside for something. What was I thinking of going out for? I need to get rice from Target. I could go out to go to Target, but like what for, I don't know. But okay, so we're gonna pull this water filter out and dump it. Yes, we are going to trash it. Boom. Just like that. I need to take out all my trash as well. My trash is about to overflow. I need to get rid of all that. Okay, so we got that. We need to clean this, so I'll pour this out into the sink. Whoosh. Now, this is pretty not clean. Has a little bit of mold developing on it. So what are we gonna do? We're going to create a sterile environment to clean this, okay? We're gonna put it on a paper towel, right? And we're gonna use paper towels to clean it with alcohol or white vinegar. Should I use white vinegar? I feel like, okay, we'll use white vinegar at first and then alcohol to finish it off. So first thing, some white vinegar. Spray it all up on that. Fold this. Let's just start cleaning it, I guess. Boom, boom, boom. Okay. Okay, I think it's doing a decent job. It's doing a job. Yeah, just the outside of this, maybe? I don't know, actually. Yeah, let's also clean the outside of it first, probably. Okay, nice strong vinegar smell, huh? Everyone loves a nice vinegar smell. Okay, just like this. Boom, like that. Okay, now it's good to touch the outside of it. To make sure our hands are good to touch, that's when we get this alcohol spray. We spray our hands with alcohol. Nice little spritz. Alcohol is disinfecting. Boom, boom. And now we're safe to touch this up. Spray some more. Now we gotta get in these corners and such. Pretty nicely in there. Boom, boom. Boom. Like this up. I think that's just hard water or whatever, so whatever. Okay, and then spray it down with some alcohol. All over. Nice and sprayed. More paper towels, yes I know. I don't have any clean towels to use, so either I wait an hour to wash and clean a towel so I can use it, or I just use a paper towel right now. So I think the better time investment is to just use a paper towel right now. But that's just me though. Okay. That is clean now. Now let's clean the inside of this. So spritz it with some vinegar. Boom, boom. Wipe the inside of this down, like so. Get it good, yep. Nice. Clean it up. Now spray it with alcohol. Okay. Another paper towel. Boom, boom. Swipe it up. Spray some on the surface as well. Okay. Now we can slot that back in safely. Now it's all good. Now we know it's clean. Spray some vinegar on the outside of this. Clean the outside of this. Boom. Okay. Now let's also spray some alcohol on top of it. And maybe on this too, why not? Let's clean this. Okay. Clean that. Boom, boom, boom. Look at that. Lovely. It's all cleaned. Boom. Do I clean the inside of the tank as well? I think the inside of the tank is fine. Like, it looks clean. And I've never done anything to really mess up the inside. I've always put filtered water into it, and it looks fine, so I'll stick with it. Okay, now this, how do we use it for the first time? How do I start it up? I think I have to wet it the first time I use it, right? Like for 60 seconds or something? I have no idea. I guess we'll just try. I think you're supposed to wet it. Right? There's like something weird on the outside of this box. This shit was not kept clean, but you know what? It's alright. I feel like this is a fake. I bought it for kind of cheap on eBay. I think next time I'll just buy the actual thing, but yeah. For now, let's put that there. Spray my hands a bit. I think I'm supposed to wet this. I believe so, so I'm gonna wet it. in the sink. Cold water on. Should I wet it with I'll wet it with the filter. Why not? Let's try that. It's cleaner water. Wet it up. Soaked up, nice and soaked up. I think I'm supposed to. I think I am. I could be screwing up by wetting it right now, but I feel like I remember having to wet it. But whatever. Okay, so it's nice and wet. Slot it into here. Ba-boom. Just like that. Yeah, there we go. And now, should be good to go. Open up this. Pour the rest of our water in. And the filter should be good. Now let's plug it back in. And I'll put it back next to my bed. Boom. Water filter replaced. Can you believe it? I can't. I wouldn't believe it even if you told me. Okay. Shit. Filter does smell kind of weird straight out the box as well, but you know. Beggars can't be choosers, am I right? I'm now gonna take out the trash. Just to make this place a little bit more sanctuary-like, you know? We gotta go through some homeworks, so I'll take out the trash. Real pants on. Let's take this trash out. This goes on this. This goes on this. This goes back here. This can go here. These can go in there. Okay. This one's starting to already explode a bit. So I'm going to take this one out first. Last one. Okay, that was the garbage. Now things are a little bit more clean, I guess. I guess it's a little bit more clean, I guess. I don't really know, I guess. Oh, I forgot one other garbage. Fuck. But I'll throw that out later. I am not hungry at all, but like I feel like I want to eat. Oh boy. Should I go to the store, get a thing of Diet Coke, and just drink that to help me through? I don't know, dude. I don't know. I could also just boil a bunch of mixed vegetables and eat that. Like, that would be healthy. I could eat a bunch of oranges. Let's do that. Let's just eat a bunch of oranges right now while... Let's watch a video. Let's eat a bunch of oranges while watching a video. What video will that be? I don't know. Don't ask me. We're gonna figure it out together. Let's watch a video. Let's watch a YouTube video. Guys. Let's do it. What should we watch, guys? What should we watch? A Veritasium video? I don't want to learn, dude. I just want to shut off my brain. M3 MacBook Air, 9 games tested. That seems cool. $1 commercial versus $10,000 commercial. Let's check.
We
this
just launched
out.
our new Feastable bar, which is new.
Is Mr. Beast 2. Mr. Beast has a 2 channel? Now wait a minute, you're telling me Mr. Beast has a 2 channel? Four oranges, and I'm gonna pour myself some almonds. Just a couple. Yes, I hate myself. How did you know? All right. Mukbang time.
New branding and an all-new formula. It tastes amazing.
I like it.
And to celebrate, I paid a bunch of people to make commercials for it, ranging from $1 all the way up to $10,000. And we're gonna see if more money equals a better commercial. Starting with this $1 commercial.
Okay.
It's just a person moving it.
They're filming their computer monitor.
This is clearly a joke. What is that?
Why wouldn't you just record on your screen?
This is probably their way of saying screw you for only paying $1.
Yeah, I can't imagine anybody would give you any care for $1.
I mean, to be honest, for $1, this is actually a lot of effort. Oh, it's over.
That was awesome.
Now, if I ran that as an ad during the Super Bowl.
No.
So far, you get what you pay for.
That sucked.
Now, let's jump over to the $50 commercial.
Now it's gonna get better.
Well, as long as they don't start drawing it. What is this?
At least they're not recording with a phone this time, though.
But there's no music.
What do you want from these
at
people?
what price-
$50.
At what price point do we get sound with our commercial?
It's getting better.
Well, it ended abruptly, okay.
Didn't really get to look at it, did we?
Yeah.
Surely the $100 commercial has audio. It does.
Matthew, no junk food. We need to start eating better.
Who made this?
So just follow me and I'll lead you right to the healthier snacks.
What is going on?
This makes me really uncomfortable, and I don't know why.
I love this.
I'm in pain.
I love it.
Way too many words.
I haven't listened to anything they've said.
What are you doing in the candy section? Looking at candy.
Get to the point.
Just look at these. Sea salt, cheese nuts.
These aren't even the new ones.
The whole point of the commercial is our new bars.
You suck. This is what it looks like now. This is what it looks like now.
Surely the $10,000 commercial will be better. Let's see the $500 one.
Feastables. Don't mind if I do.
Oh, I'm down. I love it.
Ooh. That was a cool effect.
I like that. Ooh, the hand.
This is the best thing that's ever been created.
That one?
That's pretty good. I mean, imagine you're flipping on TikTok and then you see someone just go, Feastables.
That's when you...
Ah! After watching that commercial, do you want to eat this amazing chocolate?
Yes.
Why, yes, I do.
Nice to have a feastable. I'd love to share a piece with you.
I love jingles.
This shit sucks. This channel fucking sucks. Jimmy, step it up. I need content to watch.
Today we're going to be
Let's watch
testing
this.
out games on the MacBook Air with the M3 chip. So if you didn't already know, Apple... So first up, we're looking at Resident Evil 4. So this is the remake of the game which was released late last year on macOS. Here we're running on the default settings at 1080p. Metal FX is turned on to quality mode. So this is one of the high profile Mac ports of last year. At the 1080p setting, we're fluctuating between about 40 and 55 FPS, which is not too
I
bad.
bought this game on
Apple
sale. I
port
need to
is
play
very
it,
much
dude.
scalable, so it's easily playable on the base Apple Silicon Mac, even with the M1 chip with
I need
8
to finish
gigabytes of
Metal Gear
RAM,
Solid
and it's playing
2
here
though.
nicely, even though we're only using 8 GPU cores, which is fewer cores than if you're running the MacBook Pro with the M3 chip, which has 10 GPU cores. So if you buy this game, you also get the iPhone and iPad editions, and it scales down to those platforms very nicely. This is also on sale right now, so definitely recommend picking it up, especially because you can try out the first level for free. It's a really good showcase of what Mac gaming is capable of if the games are actually optimized for the hardware that they're being played on. Next up, we are looking at the very recently released Death Stranding. So here we're running at 1080p with the graphics settings set to default, and Metal FX is turned on to quality mode. So generally speaking, we're hitting that 40.
This shit is boring too. All my videos on this channel are just boring. Like, they suck. Let's watch this. XQC.
Type 1 and you're gonna be an absolute Chad. Type 1.
Bro, I can literally show you from my end. It's like just on Discord.
Let's watch an XQC react.
On Discord, your voices overlap. You understand? So when I listen to you on Discord and I have your stream on, your voices are overlapping.
Wait, it's that fast? No shot.
Yeah, so like if you were to say the cat went to school.
It is
By the time you finish school, you're already saying the cat went. Like it's crazy like that. So you got to be careful for stream snipers. It's literally there's like no delay.
Wait, that's insane.
Let's watch an XQC video. Give me the channel.
Hey, what's up?
His main channel seems like shit, dude. All of this is shit. Let's watch this. XQC reacts to live stream fails.
Are you sure? This has increases speed. Chat. Yes, is this another port or not? It's me? Oh. Huh?
The best thing I can hear is Twins the Clown that we love bass.
Oh man.
What the fuck?
This game is okay. It seems like it's easy. Like too easy, you know? Cool. Is that like good? I'll go to my one day probably, but not. I think I had more fun time if I just like lived there for like 2 months than just visiting. Visiting would be kind of boring, no? OnlyFans.
This shit sucks, man. There's no good YouTube videos anymore. Oh, this might be good.
What if we could have a screen the size of the entire wall?
That looks amazing.
Okay. Last time we were here at the LAN Gaming Center / Badminton Hall, we tried to make the biggest possible gaming display on this 190-foot white wall. But we ran into a limitation. Our weak sauce consumer projector with its fixed lens would have me traveling through the wall in order to get the image big enough. Not to mention, it's pretty dim. So there was only one thing to do. We brought in the big guns. So with a little help from our friends at Clark's Audiovisual, we are going to be building the largest possible gaming display. I'm talking something worthy of Weird Al Yankovic. Over 2,000 inches diagonally, from all the way over there to the very far end. It's gonna be a little...
Nuts are not. Well, nuts are pretty cowardly.
We're Copilot who sponsored this video. More on those guys later. But first, let's take a look at the beast. This is the Epson Pro L1505UH, a commercial-grade projector that makes the LS12000 look like an absolute toy. Fundamentally, they're based on very similar technology. It uses, oh my god.
Check this shit out.
Okay. It uses a 3-chip laser projection system, giving it amazing contrast and, in this one's case, spectacular brightness and color performance. This thing is rated to output 12,000 lumens, and that is in color. You can kind of cheat your peak brightness rating if it's just white, but they didn't. It weighs over 50 pounds, but when you consider the performance, it's actually not that much bigger than a home cinema projector, and it's got some major benefits for an application like this. The biggest one is support for interchangeable lenses. This right here is an Epson short throw monster that is able to achieve a 0.8 throw ratio, meaning that we could get a 100-foot wide image being only 80 feet away from the wall. That, because there's another wall in the way, was incredibly important for our application, because otherwise we'd have to have this thing somewhere outside of the building over there shining through a window. What's one of these worth if I damage it? About 3,000. Actually, you know, in the world of cinema lenses, I mean, I'm not going to, but...
Oh my god.
Just in case. Nice. The rest of them pretty much boil down to easy deployment. Since companies like Clark's operate out of travel cases like these. They roll up to a show or an event, they unpack in a matter of hours, they expect everything to run perfectly, and they need to pack it all the way again in a matter of hours. So at the front of this unit, we've got what Epson calls their Pixeline camera system. This allows the unit, assuming all of the projectors have it, unfortunately we won't be using it today, to take a picture of the wall, compensate for any oddities or overlaps, and help you align all of your projectors into a giant video wall pretty much automatically. And coming around to the back, oh, look at those professional grade inputs. I mean, come on, you can't have an HDMI cable just coming unplugged in the middle of a show. Unacceptable. That's why we've got BNC, and this particular unit has support for both Control 4, which is present on the L12000, and Crestron, which is a home automation system, but realistically is so baller that it's the kind of thing that you would find at 50-inch screen and a 12,000 lumen display that, that I mentioned consumes 1,700 watts, meaning each of these requires its own power circuit. What you're looking at right now is about, give or take, a 40-foot screen, and it still looks awesome. The consumer version looks like a toy in comparison. Do you want to compare white to white? That's white. That's... Now all I need is to fix my alignment, and a game controller. Oh my god. It looks like a giant TV. Wait, does this not support HDR? No? Do you see anything about HDR support on the site?
I can't find anything with HDR.
We'll just have to try to enjoy it without HDR, I guess. What a downer. You know, I think I'd probably get over it. What's one of these worth? $15,000. I think we can use the consumer one. We'll just be smaller than that. Whee! Man, that's sick. But if one's cool, then 3 must be better. There it is, guys. We're about to show you guys how we're doing it, but first we need to talk about our sponsor, Copilot. Adam's on a little hike over there, so while he approaches, I'll talk about what it is. You get a fully featured workout app with video instructions and exercises, 3 projectors in place. What is the first step in your process?
Yeah, so the first thing we do is we get them all aligned by.
This is a vinyl record.
Lens shift built into the projectors to get them all looking roughly the same.
Huh. I mean, these two look pretty darn good. You've done this before.
Yeah, once or twice.
With that out of the way, what can you tell me about the little black box that we've got all 3 of them linked into here?
The Black Magic Box is a DataPath FX4. It's a video wall controller. So basically, what you can do is take one input source, whether it's a laptop or a game console or whatever you want it to be, and split it amongst a bunch of different screens or projectors.
And does this support the same kind of blending that we did with our commercial Quadro output that we used the last time we did something like this, or better?
It's a little bit better. Basically, what it does is it offloads that from the PC. So you're taking that, you're putting it on a standalone PC.
Okay, it definitely wasn't all me.
These
guys.
Really?
But as a team, we have built some pretty sick.
Oh man, I'm not gonna need a personal trainer after all. Sorry, sponsor. Trying one. Come on, 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 come on. Behold, the world's widest start menu. The search still sucks. Okay, who did that?
World record!
That's not a world record.
It's a Linus world record.
Behold, the much smaller troubleshooting display. Just like that.
And now we have our 1, 2, and 3 projectors.
Okay. Oh, that's something. Wait for it. Wait for it. Wait for it. Yes! Cease waiting. New plan. Forget the video wall controller. We're going back to NV surround.
The diagonal is 173 feet, which...
Wait, what?
Yeah, it doesn't make any sense.
It's only 3 feet longer than the width?
Yeah, because it's such a huge diagonal.
Even only 3 feet? That's it?
We've tried it on multiple different calculators. That's what it checks out. 32 feet tall, 170 feet wide.
Did we let down Frank?
That's 2,076 inches.
Yeah!
Frank still got it.
Here we freaking go.
Let's go!
Dan's got it. No, Dan, you do the honors. I don't think we've ever actually seen Dan game. Your pad, sir.
Thank you. All right, Spider Solitaire.
Oh, come on! Do we have sound?
I don't know if this website has sound.
Dan tried to change the volumes. Hold on, let me go tell you what it's at! Oh, it's working. Why am I even here then? Yeah, I think I can hear every bass note about 6 times. I've been to some weird parties, but this is definitely the weirdest. I'm kidding, I haven't been to any parties, but it's weird.
Sick computers over the years, and as we were going through your guys' submissions for your favorites, I gotta
give it a 7.5.
I think we should have to do integer numbers.
Okay. 8.
2.
Hey,
no
oh,
way!
There's no way this is top 25.
They literally glued rocks into a computer.
Make money
Yeah,
on
oh, who's done it before? Those imitators afterwards.
Maybe
I don't think
nobody
nobody
did
did it for a reason.
I had to wash those rocks.
Did you actually have to do that myself? I don't think you washed my
Maybe
rocks.
we did it together. It looks so half-assed.
The idea is cool. The execution is like a 6. Yeah, 6.5.
I think it shedded a lot of rocks.
Yeah, but I kept it for 6 years.
Maybe if you wash them better.
Credit to, I think it was Brandon who shot this B-roll for making this pig look lipstick.
It's not a pig.
Come on, it's
I think
not
it looks
that
great.
bad.
He hates it because all his computers are ugly. Is your current computer even built by you?
His personal rig was mostly assembled by me, and then it failed. Why did it fail?
Because it leaked.
Why did it leak?
We unplugged the thumb.
And then he built it again.
Yeah,
for the 3rd time in a month.
It is built by me though.
I still think it looks
I
great.
think it counts as extra built by me. If I paid someone to build it, then I did it again myself.
He paid his paid friend to build it, and then did it again himself.
If you want to know someone who I'm their paid friend, how about this message from our sponsor? Bridge. I mean, you guys know who they are by now, right? They've got wallets, they've got key cases, they've even got luggage, and they've got a big sale for their 11th anniversary that is happening right now. So check them out at the link down below for some massive savings. This is a 4 for me.
I'll give it a 6.5 before. I'm gonna go with 6.
Okay, 11.
Yeah, I'm not all biased. Sure thing, Geo dude. This one is deserving and should have been number 1 to 5. Am I the only one who was very surprised to see what a spectacular job Carl Jacobs and his team did of glam footaging this thing? It looks so good in their video. So he plays Minecraft on a box, and then the climax is playing it on this godly piece of computing art.
If I had to pick, I think that this is my favorite build that we've ever done, and it's nice because I didn't have to do any of it. We spent so much money on this.
I think the $100,000 price tag ended up being quite conservative.
Yeah, it was like 150 if you like account for the machining.
That sounds really expensive compared to my rocks.
I did say this is my favorite LTT build ever. It's not very practical though. I'm gonna go with a 9.
I agree, 9.
8. I don't like desk PCs.
All right.
Oh,
it's the full-on PC! Speaking of piece of builds that Luke's done.
Again, I also love it.
Wow, look at that paintwork.
Oh, this is a 3D print.
Yeah. So why is it that? It's tricky because the stuff inside is pressing against the walls. So it's deforming the shape.
So either way, you just did a bad job.
I mean, it wasn't going to fit. I challenge you to do a better job.
What purpose did these serve, Luke? I don't remember.
So those ended up being, if I remember correctly, a platform. So I could put, I think, power supply and storage or something in there.
Our modding capabilities internally have really improved a lot.
This whole entire thing was also, I think, 2 days.
I think you mean 2 days and 2 nights.
Yeah.
You and Brandon were here twice in a row until I believe 2 to 4 in the morning shooting this mess.
Yeah.
I love it when Luke does arts and crafts.
Oh my god, you made a stencil and it still looked like that.
Why did you make more than one stencil? You know you can just reuse them.
God, this is insane to think that we did this.
To Luke's credit, it was not that easy to put together a super small form factor machine back then. The hardware choices were extremely limited, and there weren't nearly as many inspirational guides to follow along with.
The whole reason why I wanted to do this was to kind of show off that graphics card, actually, because that was a sick card. Oh yeah, I used pieces of cardboard to stop it from shorting out.
So what the community's saying is they want our builds to be either Mondo Deluxe or jank garbage with cardboard.
Not garbage.
Nothing in between.
Looks great.
There's no way that this ran anything other than thermal throttled up the butt.
Oh yeah, but it functioned. Not only did multiple people get inspired by the Fallout build and build their own, but multiple people were inspired by the Amethyst build and build their own.
Why is it offensive?
You're trying to trash on all my stuff, but so far I think I have more builds in here than
Yeah, he's 50% of our top builds right now.
Let's see some builds you've done.
I think that's all of mine though.
Oh, you've got other builds. I expect the pizza warming PC to make an appearance here.
The engineering excellence is fantastic.
Okay, like 3.
11.
Thermal throttles to hell and back. Right there. That's what I think of that.
Why is there a desk?
There's a desk because there was no room to put cooling in this chassis.
Sweet computer. I love that you utilized the desk to cool it because there wasn't enough space in the thing.
Oh yeah.
That's sick. It doesn't look super sleeper to me.
I still think it was a super cool build.
Sick
This is a
build.
7.5 out of 10.
I agree with mine. 7.5 out of 10.
I did.
7 then.
7.
Yeah, 7.
Sweet build though.
Here it is.
Hey.
The number of labor hours that went into building this aluminum.
Was it 2 days and 2 nights?
so many more than 2 days.
Oh,
and
that's
2
crazy.
nights.
That's weird.
It was like 5 nights at Freddy's. This build took so long that I now have facial hair. One of the biggest challenges was getting this release mechanism to work correctly. So it had a relay, so you could make it so the head blew up.
Oh, wow.
Kind of thing. If we hadn't tried to do that, it probably could have been done in half the time. What a cool build, though.
Really cool.
Did it overheat?
No, it's got an AI for cooling, and it's got ample.
It's a little bigger than the bomb.
Airflow. Yeah, yeah.
A little bigger.
Whoa! That's a feature, not a bug. I think the objective was that if you died in Minecraft, we would have some kind of API something that would make it.
Did it do that?
No.
Hey,
my childhood Minecraft heart is giving this like an 8.
I really like this.
I think 9.
Is
Sure.
it 9? Can you stop stealing my scores?
What?
I was gonna say 9.
Oh.
You're all 8. I'm like, no, I have a different score from Jake for a change.
Oh god,
glorious.
This one is great. Look at your hair.
I think this is better than the like emo band hair.
Is this about my hair now?
Your
Is
hair?
this-
-5, like a 6.
6? Come on, really?
He's had so much worse.
I'm right here.
What is going on?
Well, we wanted to repurpose a board that we didn't care about. So we grabbed one that we had already used for sub-ambient cooling. I did not think he was going to be able to pull this off.
This was
with
so
the
cool.
teapot.
I went to go see this like in person because I thought it was so cool.
The very best part about it is either that it pours directly from the spout of the teapot onto the GPU, or the fact that we filled it with actual tea. There was no movie magic. Isn't that amazing?
It looks like tea. I don't know.
Oh, it's tea, dude. Look, I brewed this tea.
Sure, yeah, that's terrible. This whole thing was fantastic.
This is an 8 for sure for me.
It's at least a 9 for me.
Yeah.
I love this. A lot of creativity into it. Both sides of the back panel, hilarious. Using an actual teapot, fantastic. Really stand out there, designs and everything. That British flag, just every single part of this is sick. It's at least a 9 for me. This
Really? Okay, a Linus build.
And it's the tank piece.
Not the one I would have chosen.
Yeah.
Tell us about this case, Linus.
It's in the shape of a tank.
What did you do for this build?
I built it.
You put parts in a case?
Yeah, it's just a case.
But there's no like customization. There's nothing cool that you did.
It's the level of detail.
Look at this B-roll. You can't even tell. It's like miniature. This makes me feel bad about myself.
Don't watch any of my builds
Look
in
at
in
this.
quick succession. Please.
Look at that vending machine.
Most of the coolness was not done by us.
This was all nerd forward, all the way. They did an amazing job. It was one of those things where they said, it's our gift to you, the machine. And I was like, oh my God, I want someone to daily drive this thing.
Yeah,
so we ended up auctioning it for charity at LTX. We raised a bunch of money for charity, so massive shout out nerd forge for that as well.
I do agree with community vote here.
11.
Yeah.
And not a Luke 11, like a real one.
Yeah.
We should do another build with them.
I think what we should do right now is talk about which builds we think are missing from this list. Where's your copper tube, PC?
That was not that exciting.
Compared to the tank?
Oh my god. I had to learn how to bend a copper pipe in a way that didn't look like it. I ended up getting the actual final method from Bob and Rod, I think. The big thing was finding a bender that actually had the same diameter as the outside of the tube, and then filling it with sand so it doesn't crush.
Well, awesome at the end after all the sanding and polishing. He actually used this as his daily driver workstation here at work for like 2 or 3 years. Yeah.
Until the DDC died.
Oh, okay. This is Linus build?
What?
I mean, I built it.
You put a kit together.
Yeah,
Good job.
congratulations.
Everyone can play Lego.
Yeah. Audience, let us know. Whose build is this? Hey, look, it's me. Wow, I wonder why I'm there. Oh, look, it's me again. Wow. This case is like the stupidest case ever, but also I love it.
It's so cool. It weighed a ton. It's a single, what was it, just cast aluminum thing.
Hand finished, hand polished.
Yeah.
I think it's $5,000 US or something like that. And they only made
Nice.
and said that straight to his face.
Nice.
And I didn't break a single line. I don't know if I ever told you that before.
Yes, you have.
Really? Oh yeah, I totally lied.
Why am I the one with the nickname Lie? No. I didn't lie about anything.
Both of
You
us
two, on the
lied
other hand,
about our space.
the resume fraud duo. This brick of raw GPU-ness delighted me more than I could have possibly expressed in the video. Plugging in 7 GPUs. The resume fraud duo. This brick of raw GPU-ness delighted me more than I could have possibly expressed in the video. Plugging in 7 GPUs.
One movement?
All at once.
Yeah.
I haven't done it before. I haven't done it since. It's so cool.
That was like hard, never done before. Yeah. That was really cool.
Cool thing.
Yeah, see, he actually built a computer.
I do cool stuff.
Yeah, I mean, sure.
This was one of my favorite collabs.
This was really cool.
Yeah. Shank is so cool.
Yeah.
And this build is amazing. I missed it. I wasn't able to
remember
be
that.
here for
Yes,
this.
yeah.
I was so upset.
I'm pretty sure you said
It
it.
looked like that in one of the videos we were watching earlier.
Yeah, you want to rate my hair again?
Oh my god, the
That
monitor!
is so cool.
I forgot about the monitor.
This is a 10.
I really like that it's like the whole thing.
It's glorious.
Isn't that monitor like stupid expensive?
It's an Alienware thing, right?
It's stupid and stupid expensive.
Oh yes, this thing is awesome. This looks like a normal computer.
Yep, everything's fine. It looks way better than the Amethyst machine because it's not full of stupid rocks.
Disagree, it looks boring. I'm bored.
Oh yeah? Are you bored now, son?
No.
Oh, the wig. Oh yes.
There we go. Rate my hair.
That's an improvement.
Better, yeah, for sure.
And remember, this is going through the computer. Like, there's some leakage.
This is just dumb. What? This is the point you realize that?
I love that build. It cooled really well. It was super effective.
this is
It's here.
fantastic.
Here it is. Called it.
This is probably the best thing I've ever done.
You look just like you hate everything.
I did. I think I was like, this video's horrible. I'll try to make it more interesting by asking the Panago guy how to heat pizza with a computer.
You didn't understand the damn video. It wasn't to heat the computer. It was to keep it from cooling down.
Yeah.
So I arrive on set, and there's a cold pizza sitting there. And I'm like, why is the pizza cold? And he's like, so we can warm it up with the computer. I'm like, oh my god, no. We're supposed to have a pizza on the computer warming pan and a control pizza that's just cooling down, and we're supposed to track the temperature decline over time.
Things were very well planned.
I heard this crazy thing called an insulated bag.
Mark me. We are redoing the pizza warming PC. We're doing it this year.
You know, you might actually be able to heat up a cold piece of pizza now, just because of how much power computers drop.
This is actually true.
Like 24090s and like a 13900.
Pizza warming PC may be viable now. Oh wow. I think this is recency bias. This build sucks. It's like a 4. It's so stupid. I love Elijah, but like
I definitely wouldn't want it, but it's a fun video.
This computer was awful, and none of the screens worked.
They worked.
No, I know they worked after Elijah spent like a week getting them to work.
Yeah.
Why not 2 nights? What do you mean?
Hey, I like this
The
one.
hack. The hack pro. Speaking
I
of
totally
builds
forgot about this, but this is cool.
that were a nightmare to get going.
How many videos are there? It's finally done.
Such a cool chassis, like blackout
I love it.
cheese grater, and this system ended up being wicked fast.
It looks very cool.
Look at this system though.
Yeah, like this was sick.
It has a phase change cooling system in the
It is.
basement.
Yeah.
We still have this case.
Like, are you actually someone offered to buy it?
Yeah, we still have it.
Yesterday.
Like we had it for the longest
Should I
time.
sell it for $400?
I feel like it's worth more than $400.
I think it's worth a lot more than $400, but it's been taking up space for.
I think you should just give it to.
Amazing.
It helps that I thought the OG Xbox console itself looked super cool.
Getting all that stuff in there, not easy. It was a thing. Some people would be upset at us for taking it. Oh my god, this card. Covered in masking tape.
Why is it taped like that?
Is it from metal shards?
yeah.
Oh my god, right, because he sawed off the connector. Hey, look at all the metal that was in the graphics card. What was that?
I have a bit of a thing for hot rodding stuff through the side of the case. Apparently I get credit for this one because this is me. But look at the side of this computer.
That's sweet. That's cool.
Passive cooling, baby!
Yeah, that's wicked.
So here's another all radiator PC. Yep. So that's what the water looked like.
I think that face encapsulates how I feel about this computer.
Sus.
Those are usually filled with oil, right?
Yeah.
So like,
We cleaned it
it out.
Oh, yeah, it didn't matter, though.
Oh, yeah, 100%. It worked great, though. This thing cooled like a hot damn. She's a 10, boys. She's a 10.
The side panel. If only you could actually order that from AliExpress. Wait, did he etch it on the wrong side?
Yeah.
Oh, that's great. God. The Colton dancing is the best part.
No, the best part is the segue to our sponsor.
Okay. Is that it for React video time? I don't want to actually... You know, all I have to do is just look through these homeworks. That's all I have to do. Right? That's it. That, bring this over here, attach it to that. I think that's it, right? Yes. The rest are the solutions. Okay, looking at number 4. I'm already getting tired, bro. I might not pull an all-nighter. I don't think an all-nighter is required. Instead, let's just go through these. Oh, I fucking hate that. Oh, stop being negative. I gotta be positive. Posy vibes only, guys. Posy vibes only. What song should we play to get us into positive vibes? I don't know. Miss the Rage is a pretty good one.
Hey man, where the fuck is Mario Judah?
I miss the rage.
I miss the rage. I miss the rage. I miss the rage.
Oh yeah, baby.
I miss the rage. I miss the rage. I miss the rage.
I miss the things we had. I remember it all. I never said that I was that. I remember it all. I miss the things we had. I remember it all. Yo, I just found a fire YouTube video actually.
Hey guys, welcome back to another video.
Guys,
today I decided to
fire YouTube video
do
time
something
actually.
special for the 2 mil. We got 3 of those. Hey guys, welcome back to another. I decided
Why
to
the
revive someone's
fuck
career.
this has happened?
This man sadly fell off. He had a little fall off, but you know we're gonna bring him back. We got Moist Pancakes, is it?
Yeah, that's the one. Hey, thanks, brother. I've been looking.
Why does that happen? It was like still playing the audio even though I dragged it into here.
But today I decided to, you know, do something special for the 2 mil. We got 3 of those. This is one of them.
Let's
I
watch
decided
this.
to revive someone's career. This man sadly fell off. He had a little fall off, but you know we're gonna bring him back. We got Moist Pancakes, is it?
Yeah, that's the one. Hey, thanks, brother. I've been looking for these handouts. I've been needing them. I've been scraping by. We're struggling these days, so this means a lot to me.
All right, dope. All right, guys. We're gonna do a plain cheeseburger tier list. Every time we get a new burger, I'm gonna ask him a deep, dark question. So we're gonna learn something from this man, right?
Hey, I'm excited. I'm an open book.
All right.
I don't know what brain busters you have, but I'm sure they're pretty easy.
Do you have a friend zone memory?
Yeah. Oh yeah. I got a few to choose from. I'll choose the most crushing. Yeah, but I'm sure they're pretty easy.
Do you have a friend zone memory?
Yeah. Oh yeah. I got a few to choose from. I'll choose the most crushing.
This is the real me, in case you guys don't know. So this is the real tub. And we recently went to a place called Busch Gardens Adventure Island, just a theme park here. And you know they're doing caricatures. So I was like,
yeah, you gotta get one of those.
I know. So I was like, all right,
Classic.
let's make it count. This is really me. This is no filter, by the way.
I'm excited.
Yeah.
Oh wow.
Yeah.
That looks almost AI generated. It's so good. They're missing your 8-pack. They only put 6 there for some reason.
I know. That's why I didn't step on. No, just kidding. All right, yeah, that's like you could keep driving. All right, guys. So we recently picked up McDonald's plain cheeseburger, fries, and a milkshake. We did the same with Burger King and what's this one called?
Culver's.
Culver's. Is this exclusive to?
Nope. No, but
Nice.
they're probably one of my favorite fast food restaurants. They just do a really good job. They put real love and soul into their work.
Okay, I'm excited for that one. So first, we're gonna try McDonald's. So presentation-wise.
Everyone's had McDonald's. I think
Yeah.
we all know what to expect.
Duh. Presentation-wise, I like the shake better than Burger King already. McDonald's, you know, that shit comes in clutch. We got small of everything. No ketchup either, just dry.
Just, yep, the
Just
way
straight
God
bread.
intended.
Yep.
No condiments, just a real sad old McDonald's cheeseburger in a Big Lots parking lot.
Jesus.
what is interesting about the burger is that the cheese isn't fully melted like 80% of the time.
Yeah, that's part of his character though.
Yeah. This is a classic for me. In case you guys are wondering, I got a little backstory on plain cheeseburgers. I don't know if you were the same, but this is all I would eat as a kid.
No, when I used to like really engorge when I was young, 3 supersized fries back before they outlawed it with the Geneva Convention.
Supersized fries?
3 supersized fries.
Is that just like extra large fries?
It's above large. So they stopped it after the supersized documentary came out. And
Yeah.
this shit's killing us.
You didn't have a burger face?
No burger, no filet-o-fish, nothing.
What?
3 supersized fries.
Yo. Okay. Hold on.
For some reason, I was just addicted to French fries. So if I went to restaurants too, just fries. nothing else.
McDonald's fries
Nothing.
are
Yeah, shit was great.
amazing though. By far,
As I was saying,
they
I
are
went to
the
my mom.
best
I was scared.
fries.
I'm like, Mom, what about when I get a girlfriend? It's gonna be embarrassing asking for plain cheeseburgers. I'm guessing you got the same thing with fries, maybe.
No.
No? You proud about it?
No, girls just never crossed my mind. I was like, no chance.
Oh.
I'll be alone forever.
I was scared. And to this day, you would be eating plain cheeseburgers. So plain cheeseburger, I got it. But, you know, I can indulge in some tomato, some pickle, some diced onions.
Probably some flavor of any kind.
The way we're gonna rate this overall, let me try the fries. You can't go wrong, dude. Oh my god.
I've always considered those the gold standard of fast food fries.
Yeah.
Like, they're not doing anything spectacular. They're fighting in their weight class. They're doing a good job of it, and I respect it.
There's something calming about them.
Yeah, it's very tranquil.
Like, oh my god.
A peaceful comfort of the consistency.
There you go.
Thanks, brother.
Time for the vanilla shake, but we're doing S tier, S, A, B, C, D.
Okay. And he took a big swig.
Yo, it's hard to suck. Pause. Just like it has coffee in it.
That might just be the way they do things.
I swear it's 6 hints of coffee.
No, you're on the crack pipe. That's just vanilla.
What?
Yeah, 100% that's just vanilla. I'll tell you right now.
Bro, there's fucking coffee in it. There's coffee.
You want to give it to him for the tiebreaker? I'm telling you. That is just vanilla.
And be honest. Be honest.
Maybe a little like caramel swirl at the bottom, perhaps.
Maybe that's what they put. Or was that Burger King?
No, that was Burger King.
Oh, okay. Fuck you. Whatever. Anyway. I give this an A.
Oh, you are on the crack pipe. It's a B. It's just so standard.
Bro, but no, but it's like if it's a go-to, then it's an A.
Okay.
If it's a go-to, then it's an A.
Well, it wouldn't be a go-to though. It's like, hey, I've got nothing else. I'm like kind of stranded here. I'm kind of lost. I'll go to McDonald's. That's like you choose anything else over like McDonald's. You know what I mean?
Do you? You would choose Burger King over McDonald's? Well, I guess we're about to find out.
Don't you ever say that. Near me again. Burger King is a scourge. Burger King is an affront to God that it still is open.
Let's put it to the test. Let's see Burger King. You want to do separate two?
It's not that bad.
Okay, so we'll settle for.
A lot of people hate
S.
on Burger
Hey,
King.
here's
It's
the second
really
option.
not that
Hey,
bad.
who's wants to be a Burger King?
I have it like once every 6 months for all these fucking like tier list videos we do. So
The fries
it's
at
like
Burger
fucking
King are
standard.
decent.
I'm already in love, bro. All right, presentation. Sesame seeds. I love that already. It's the same thing where like the cheese isn't like on the corners. It's not really that melted.
All right, they brought their A game with these fries though. Goddamn it.
Burger fries are amazing.
Usually their fries aren't this good, but they finally season them properly.
You don't like their fries usually?
Every time I have them, it's either all salt, no salt, or all potato. Those are pretty good though. That's the Burger King quality I expect from a sewage burger.
I'm gonna be 80 pounds heavy after this video.
Yeah, but then you start pumping it out,
Duh.
you get jacked.
By the way, guys, next time we have with Charlie, I told myself, I told him, I'm gonna get jacked. I'm gonna have pecs, and I'm gonna have a six pack. You guys hold me accountable. I'm gonna start working out, like for real. So y'all gonna see. This is the last of it, you know. You're not gonna catch me eating this on camera at least.
Gotta savor it. Dive into this milkshake if you don't mind. It's not good.
No.
McDonald's one's better. I thought it'd be worse. I watched them make that. I don't know if anyone is familiar with the Burger King secret recipe, but they start with the cup, and then they put some kind of like grease or oil at the bottom. Then they put the ice cream in, and then they have a machine that swirls it around really quick, and then they do another layer.
They put fucking engine oil because it's not good.
Yeah, it's not very good.
I don't know what weird aftertaste.
I don't know what that oil is at the bottom, but I do not like it.
It kind of tastes like a toothpaste. I get like a toothpaste taste.
A little bit. It's like almost medicinal.
What does that? What
Jesus.
does that mean? Medicinal?
Medicinal.
Is it medicinal?
That is what I said. Medicinal.
No, you're saying medicinal, right?
Yeah,
I know. I said medicinal.
Oh.
All right, that's a tier below.
Absolutely.
Yeah, that's B. According to our list, that's a B.
I would give it a C, but you're right. Since we're meeting in the middle.
Yeah.
Normally this would be a D, but the fries saved them for me.
Yeah.
They actually did a good job on the fries. I gotta give credit where credit's due. The fry connoisseur back there. You came in. You came to play.
The goal is to get an S out of today, and it looks like you've been hyping up something.
I hype up Culver's a lot. I think Culver's goes crazy. They do crinkle fries too, which is kind
Oh,
of
do they? Okay, I'm gonna ask you 3 questions after this. I've been forgetting to ask you the questions.
Oh yeah, I forgot that was part of this. This has just been my lunch. This one I might finish. Now this is how a burger is supposed to be.
Oh, the fries, they blend so perfectly.
Oh hey, fuck yeah, that wasn't even trying to make that reference.
This is how bacon is supposed to be. The fries, they blend so perfectly.
But you see, like they really care. Each inch of this has purpose. It's not just thrown in there haphazardly.
Like the cheese up in here is going
They
hey-o.
do such a good job.
Let's see this. And I'll be honest too.
Yeah, to be honest, I think they do a great job.
Okay, you get a sip of something. I guess I'm gonna try this first. Oh, it's hard to suck up. Pause. That's like average.
Average?
Yeah.
I've never had their shake. They do custard there. Their big thing is
Oh, really?
custard.
Yeah, I think the shake is pretty average.
I don't know. I think it's pretty good. You think McDonald's is better than that?
Yes. The shake, yes. Even though I said it has like a coffee taste, yes.
Can I have him come in here because I think you were actually crazy?
Yeah, okay.
I think that is significantly better.
Really?
Yeah, and not even close.
It's true to vanilla. I'll give it that. It's
much-
true to vanilla.
Very true to vanilla. Oh, okay.
All right.
That was overwhelming. Yeah. We got no closure.
Let's see the burger. This is the real hype.
I think the burger is fantastic.
Bro, wait, hold up.
That's what happens when there's passion in the food. You can taste the love from
It doesn't taste manufactured.
No, it's real.
Yeah.
That's real red-blooded patriotism in a bun.
Hold up. You gotta do the. You have something to treat, but you drink. You know, the classic. You don't do that?
No, I don't do that. But
Damn, I look like a fucking weirdo
no,
now.
it's not weird. Everyone enjoys Culver's differently.
You know what it reminds me of? I don't know if you guys have it here. I think it's just a California thing. There's a place called Foster's Freeze. No.
Never heard of it.
It's a little. It's not.
Wait,
oh,
you're
yeah, the fries.
neglecting the fries.
Shout out Foster's Freeze and Hawthorne. This is good though.
Yeah.
This is the best burger out of all of them so far. Not go to, but like the reason I have it at McDonald's is because it's always there. That's why I have it up. Because it's always there and it's decent.
Yeah, I agree.
This is good. Like taste flavor wise, this is the best burger out of all these so far.
Try these fries though. Your eyes about to roll in the back of your head. You got a one-way treat to Flavor Town, brother. Enjoy it.
Bro, these with ketchup will go stupid.
I know, right?
These with ketchup will go dumb, bro. What the fuck? Again, like what I said about this is true to vanilla. This is true to like a fry.
Yeah, like the American dream, basically.
That was worth the hype.
No, I totally get it. Culver's doesn't disappoint.
I wouldn't mind putting this S tier just because the shake is the definition of vanilla shake.
Why the
There's no
fuck
like
am I just
add-ons, no,
watching
like-
people
it's
eat?
not the advantage.
I'm just
Fucking
watching people
What's
eat
the
fucking
Culver's?
You know
food.
Calvin and
What the fuck am I doing?
Like a southern chain, I don't know, but it is a chain.
I'm
Damn,
cooling
I
down
thought the
before I
burger-
dive into the more
What do you
shit.
All right, first up, we got. What's your address? No, this is an interesting one. What is your earliest memory?
Like as a human being?
Yes, as a human being.
I remember I had this bear. I still have a bear. His name is Bear. And I remember I was in a crib with him, like one of those like standing ones that you see in ghost videos a lot, where like they get possessed or whatever.
Yeah.
And I had the bear and I was jumping up and down with him. I remember that. That's the only like baby memory I have though.
Wait, you're a Tampa native? Like, that happened in Tampa?
That happened in Tampa.
Holy shit. My earliest memory. Thanks for asking. Returning the question.
Yeah, sorry.
So,
what's your earliest memory?
My earliest memory. You want some surprise?
No, I'm just killing these in the bag.
No.
Be ashamed one go to waste.
My earliest memory? A TV. I was it wasn't a crib, but it's like those baby seats that you put in the car, like right here, those baby seats, right? Like those types, but they're hybrids, so you can also like have them in the house. It was aiming, or I guess I was just looking up.
I don't really give a shit.
How did the
Post Malone was like, man. Like,
I didn't know you met him.
Yeah, I don't like fangirl about anyone or anything but him. Butterflies my tummy. If he asked me to suck his dick right there, I did music since college. Like that was the soundtrack to my college. I got the chance to meet him for my birthday actually. Went to his concert, best concert I've ever been to. We played the finals together too, which was hype. But meeting Post Malone was like, man. Like,
I didn't know you met him.
Yeah, I don't like fangirl about anyone or anything but him. Butterflies my tummy. If he asked me to suck his dick right there, I would have done it. I wouldn't have even hesitated.
When was this?
August.
Oh,
my 29th birthday.
it was like most recent birthday.
Oh yeah.
Oh shit, what the fuck? Did he like backstage passes or something?
Yeah, we talked. He reached out and we talked.
He cheated. But hey, I'm playing.
I don't know, like I don't get into like celebrity worship type shit, but he's like a different breed, man. This is like
no, dude, he looks like the nicest soul ever.
He's honestly such a nice person.
Remember the dude that went up to him and was like, "Fuck you" or something like that?
Oh yeah,
And
he's
then
like,
I was like, why? He's like that.
That broke my fucking heart. What about you? Who are you excited to meet?
Danny DeVito.
You met him?
No, I would. I guess okay. Cop out answer was you. It was you.
Oh, it's up to you.
Yeah,
Okay.
but
Oh my God.
but like other than that, I want to meet Danny DeVito.
Danny DeVito would be an absolute legend to meet,
Yeah,
for sure.
I'm trying to think like who have I met that I was like, yo, like I'm in the same room. I mean, I want to meet Anthony Padilla from Smosh. I want to go on the.
Oh, Day in the Life.
Yeah, I want to do that. Yeah, Anthony Padilla. If you're watching this video,
Hey, he's always on the grind, man. They'll probably reach out to you after this one and be like, talk about that Culver's rating. Really that good?
Other than that, like who have I met? Like who you know that I met like that I posted on Instagram? Face Rug. No, it wasn't that. I mean, of course, like shout out Rug, but like
that was cool. It was cool, but
he mentioned when I met him, he mentioned like something that I met. Like if I met Danny DeVito.
Oh, nice. You found his agent.
Cool.
That would be cool.
Now third question. Dumbest purchase. Your dumbest purchase.
I've made a couple that I regret. I don't really spend a ton of money, but
yeah, so I thought it would be a good question.
Yeah, but the ones I do spend it on are always kind of stupid. I don't know what the dumbest would be. One that I always mention for something like that is I bought a pocket trumpet for like $200, and I debated hard on the pocket trumpet for a minute.
What is that? What's a pocket trumpet?
It's like a little bugle, basically. I was really into collecting weird instruments for a while, and I went to Sam Ash and I saw they had a pocket trumpet. I was like, fuck, it's $200, but I kind of need that pocket trumpet, so I got a pocket trumpet.
Wow, that's your dumbest purchase?
I don't know, I just felt really regretful. I never learned to play it, and immediately started to rust because I didn't take care of it. Like it just seemed like such a waste because I know someone could have used it. But other than that, I guess maybe like a Moby Huge, the 3-foot dildos.
No, that was one of your best purchases. What do you mean dumbest?
I don't know, I bought 6 of them though. I didn't need 6.
You bought 6? Why did you buy 6?
I kept trying to repurpose them, so we have like a Moby Huge car. We have a Moby Huge for target practice. And I was like,
that commented on my Discord and was like, yo, in 2021.
Smart.
Yeah. Hookers, no, maybe. There was one.
There's still time. We can still make that happen.
We're gonna go by what? Two more.
No offense to his YouTuber. I'm not watching this
Wendy's
for
and
him.
Checkers. Checkers is Rallies. Do you know why they have different names?
I think it's probably different owners.
Yeah.
Same thing, different owners, I guess, in the franchise.
Interesting.
And the questions are
this one's Rallies,
really
but we'll call it Checkers for this video. Checkers Rallies. We're gonna start with Wendy's.
No fries?
No.
Yeah, no fries.
They fucked us.
I imagine we all know what the Wendy's fries taste like anyway.
Dude, I don't even remember what they taste like.
Wait, really?
No, I don't eat Wendy's that often.
Oh.
All right. Well, leaning towards our first D.
Really?
Yeah, what do you mean?
We're on different ends of the spectrum on that one. I actually like Wendy's burgers.
Really?
Yeah.
They're good, but like compared to what we've had, bro.
Well, it's because we just had Culver's, so your taste buds are still like cloud 9 right now.
It could be, okay, maybe not D, but maybe behind Burger. Or you would say this is in front of Burger King.
This would be definitely in front of Burger King. I put it in front of McDonald's as well.
Really?
I absolutely would. Here, also, you haven't had the Frosty yet.
Presentation-wise, it's interesting to give us a spoon. They're like aware that they're hard to suck up.
Yeah, it's just more of an ice cream than a milkshake.
True, but this is goated.
It is good, man.
Oh, okay.
Frosties are always good.
Yo, this is good, yeah. All right, let's put this in front of McDonald's and Burger King, but under Culver's.
So an A.
Yes.
A. We made it. I agree with A.
Okay,
I
it's
absolutely,
good.
I think it deserves an A.
It's good.
I think it just always hits when it needs to.
Oh yeah.
You're excited for the burger, I'm excited for the fries.
Dude, no, both of them. You don't know.
I love the fries.
You don't know the tub method, bro.
What's the tub method?
Yeah, you gotta do this. You gotta put the fry, take a bite.
You get the little bumper on it.
Yep. It is dry, to be fair. I'm used to like, not so dry. I usually get it just without tomato. It's dry. They're all kind of dry, honestly.
Except Culver's. Culver's, even when nothing's on it, umami.
I love it, but I'm not because I ordered like a different order. I like it, I don't love it. That's what I'll say. It's good. But I feel like that doesn't do it justice.
Like a mouthful of sand.
It's really dry.
That's exceptionally dry.
I know.
What a shame.
I know.
What a shame.
Damn, that's a fucking D.
That's a D.
What?
The fries definitely. It's the meal. The burger may have been a D, but the fries. S.
That's S. Oh my god, goated. Do you use the word goated?
Sometimes.
Oh, yeah.
I've been using fire a lot recently.
Really? You know, like, that's flames.
I don't think that.
Alright. Shake time. Yo, this might be the best one.
Really? Hold on.
I don't know if they got an upper hand because that we drove. I don't know what it is, but it's easy to suck up.
Okay. The viscosity is where it needs to be.
It's another one that's like true to vanilla.
Oh,
right?
that's good.
Right? I would love to order a vanilla shake and it's already like
ready to
yeah,
consume.
Yeah.
That's super good. I've never had
I know.
vanilla shakes
That is
before.
so sad for Checkers that their burger was so fucking dry.
Yeah.
They could have gone S.
They were on the cusp.
Holy
I
shit.
still give them an A even with that.
Because the burger was too ass, bro. You can't do
Yeah,
an A. B.
okay.
B. Low B.
All right.
Here is our tier list. Culver's 1. Oh no, what's at the very end? Do you know, Andrew? Have you check? Burger King. Culver's 1. Amazing meal. Burger King. Y'all gotta do better, bro. Y'all gotta hire me. Y'all gotta hire me.
You gotta just close down. Just call it quits, man. It's been like 60 years.
All right, so let's get on the questions. We got 2 more. Okay, that's the good ones.
Just
favorite
call
Cartoon
it
Network show?
quits.
Any era.
Perfect Family Dog.
Yeah, I agree.
It's my favorite cartoon in general. I think it's perfect.
You should tattoo it.
I thought about it. Actually, when I was doing my first tattoo, I didn't know if I wanted something that meant anything or if it looked cool. I was thinking Courage the Cowardly Dog or the Halo Legendary symbol. I was such a big Halo guy.
Yeah, yeah.
I decided on either.
Your favorite's Halo 2, right?
Yep, Halo 2.
My favorite, Halo 3.
Halo 3 is so
I love
fun.
Halo 3. Playing with my friends, we just hop on the ghosts and we would do ghost battles. And just keep crashing together and see who would.
A few to choose from. I'll choose the most crushing. The first girl I ever asked out was in 8th grade. Her name was Kaylee. And the way I asked her out was on the very last day of 8th grade. You know, you do like signing into yearbooks and shit?
Yeah.
I left her, I was like, can you sign my yearbook? Also, will you go out with me? And then she he was stunned, obviously, because that's a big request.
Yeah.
And she's like, it's the last day of school. And that was it, and then like walked away from me. But that wasn't the last time I saw her.
Really?
She was friends with my friends. And she never gave me an answer, so I was assuming she was thinking it over.
Yeah.
I didn't come to terms like, oh no, she's not gonna date me. So we
You were
ended up
accepting
no,
it?
I thought she was
I need
like,
the
oh. She's like, hey,
prestige
it's the last day of
master.
school. What do you mean? Oh, okay, so she got some time to think. Okay. We went to the mall like a week later. My friend group and her friends went. And she started making out with my friend in the seat next to me. And I had to watch it. The movie we watched was What Happens in Vegas with Ashton Kutcher. And I can't, like, whenever I see that movie, I think of that trauma where I was like, man, that broke me. I was so sad. I was so sad.
Did that friend know that you want her?
Yeah, but I mean, he also knew that it was definitely a no. Like, when I told him the situation,
Okay.
he was too nice to tell me, I guess. So
That's fucked up.
He had to show me.
Dude, that's fucked up. First of all,
That hurt.
How old were you, like, what, 13, 14?
I would have been, I think I would have been 13 at that time because I turned 14 going into high school.
Holy shit. 13-year-old Charlie, I'm so sorry I had to go through that.
That hurt.
Oh my god, and I wish looks maxing was a thing back then.
If only I could mew. Like, go back in time and start mewing would have changed everything for me.
I know what can make Charlie feel better. I got him 3 gifts. I have 3 gifts. So last time I got you a goat. I got you goatee.
And it's on my shelf still, on my shelf.
Where?
In my room.
Oh, in your actual room?
In my actual room, yeah.
Is Dragon's Dogma 2 actually good?
What? You've no memories, you say?
He also refuses to blink. He's got crazy eyes. Oh, he blinked. He heard me.
You could make for Melv then.
This game kind of
No
looks
crash
shitty.
yet, that's
I'm
good.
not gonna lie.
You're most vulnerable when taming your magics. Take care not to get exposed to your tuning.
Oh, shit.
Welcome back to another episode of Before You Die, the show where we give you some straight up gameplay and our first impressions of the latest games releasing. Just a few years ago, I'd have told you this isn't going to happen, but it's here. I'm playing it. It's Dragon's Dogma 2, against all odds. The original game from 2012 is a deeply weird, kind of janky experience that was begging for a more refined follow-up that never really materialized until now, almost 12 years later. Capcom could have easily taken a safer route and turned this into a medieval fantasy-themed Monster Hunter game, but instead they made a relentlessly faithful follow-up to the original that is still a little weird and a little janky, but utterly enthralling. It is not a perfect game, but Dragon's Dogma 2 is one of the most intriguing and exciting AAA games I've played in a very long time. There are things about this game that some people are going to hate for sure. It's got some obtuse quests, some pretty oddball gameplay systems that go relatively unexplained, some inconsistent frame rate, and extremely low-key opening hours, but in a lot of ways, this is kind of the anti-AAA. It zigs where most games zag, and while that may be disorienting for some out there, I'm gonna say I really like it. So what the hell even is this game? It's hard to explain if you haven't played the first one. If you have, it's like that. It's an action RPG where you make your character, pick a class, and explore a big open world. On the most basic level, it sounds indistinguishable from most high-profile action RPGs, but this game, it's really not exactly like anything else out there. The combat's a little like Monster Hunter, where a lot of the beasts you take on are these gigantic enemies that you can climb on, target weak points, etc., but instead of going it alone, or with a party of other players, Dragon's Dogma has you team up with 3 pawns. These are AI-controlled allies that have their own complex rules governing their behavior. There is no multiplayer in this game, so if that's what you're looking for, you're not gonna find it. I would argue there's plenty of other things to look for, though. There's the quests, which tend to be very open-ended, and the extremely systematic game world with day and night cycles and NPCs with schedules. It's sort of like Monster Hunter had a weird baby with Skyrim, but I don't know that accurately captures how odd this game is. It's one of those things where you just have to play it, or at least see it for a while to get what's really going on. Unlike the first game, which took way too long to get you into the open world, this one starts with a short prologue where you create your character using the game's frankly really impressive character creation tools, and then pretty well drops you into the game. If you so desire, you can totally ignore the main quest and start exploring in random directions. It's up to you. As an example of just how open this game can be, there's a quest where the soldiers are escorting you back to the capital. In any other game, this would be some scripted thing where you're forced to follow this guy, but there's nothing stopping you from going off the beaten path and getting him killed by mistake. And if you fail the quest, there's no restarting. You just have to make your way to the capital on your own. Later on, there's a gate that keeps you from entering a southern section of the map. In any other game, this would be locked by plot progression, but in Dragon's Dogma 2, there's other ways of getting past. There's just a level of freedom you rarely see in a game that is on this scale. There's multiple ways to resolve quests. You can access certain locations earlier than you're supposed to. You can kill plot critical characters, and everything just keeps going. The actual presentation on all this stuff isn't always that impressive, to be fair. There are a few full cutscenes, but your character is a classic mute RPG protagonist. Most of the dialogue is done through basic text, the old text box technique, and characters just standing somewhere. It's functional, but pretty bare bones compared to the presentation in a lot of other modern RPGs. The game is just really unusual in that most of the main quests are pretty flat and simple. Go here and get that sort of things. Rarely does the main quest even directly force you into a fight. Most of the combat in this game is incidental to exploring rather than a driving force of the story. It's not like Monster Hunter where every main quest is to hunt a new monster. It's more like you're going somewhere and there just so happens to be a monster in your way. Side quests can be a little more complex with multiple possible outcomes depending on what you decide to do. This game never gives you a Bethesda-style drop-down list of choices. The things you do are entirely up to you, and it's both liberating and potentially frustrating depending on exactly how you drive with it. For example, what I'm talking about is a quest called Hunt for the Jadeite Orb, where a guy had this orb stolen. He had an orb, and somebody took the orb. There's 2 guys who want it, and you can just find the orb and hand it over to either of them if you want. But if you really want to resolve the quest in the best way, you go to the local item forger and get a duplicate made of the orb, and you give the crappy one to the jerk and the real one to the nice guy, and you get a better reward. None of how this plays out is signposted or explained other than the general quest area where these guys appear. Beyond that, it just leaves you up to figure this stuff out, and when you do, it feels awesome. I really like knowing that everybody is satisfied with their orb. Even though one of the orbs is clearly inferior, they don't know that, and I don't have to stick around to find out if anybody gets orb regret. I just move right on. The game does have a few systems to help you out, though, like the pawns, for example, who, depending on their experience, may be able to guide you during a certain quest, but that usually just boils down to taking you to a specific place, and I mean, that's it. This can be extremely helpful during certain quests, don't get me wrong, but they're not going to explain any fine details of anything for you. There's also an oracle who's about equally as helpful, and when I say that, what I mean is not that helpful. On the subject of pawns, yes, they're better than they were in the first game, and yes, they don't talk as much. They still talk too much and repeat certain lines a lot. Like, do you really need to point out that same ladder every time I pass by it? I don't think you do. But overall, again, they talk a lot less and act more intelligently in battle. Pawns are what make combat in Dragon's Dogma feel unlike any other RPG, because you're rolling with a team of 3 AI assistants that can only be given 4 vague commands like come here and help, which might make them sound kind of worthless, but if you build a solid team, they can practically win battles for you. You can obtain pawns from these rift stones. There's one main pawn you design yourself, and then you can bring along 2 guest pawns, which are the ones you obtain by using rift stones and spending in-game currency called rift crystals. Pawns on your own level are always free, but higher level pawns cost more, and depending on your settings, the ones you see in the rift will either be pawns created by other players or pawns created by Capcom. There's a whole lot to talk about here with these things, how they work, what they do, but I'm going to give you the short version here and say that they work. They work really well, actually, and while you'll be swapping out guest pawns a lot because they can't gain experience in your world, finding new and better pawns is always satisfying.
Seems like a very interesting
pawns created by the players
game.
or pawns created by Capcom. There's a whole
But
lot to talk about here with
visually,
these things.
why is it like so
how they
flat?
work, what
Like the coloring, the color
actually.
grading.
And while you'll be swapping out guest pawns a lot because they can't gain experience in your world, finding new and better pawns is always satisfying. Another thing I appreciate is there's not that much menu busy work in this game. There's basic crafting, but you're only making a few specific items. There's skills and different jobs to unlock, but those are only accessed at certain vendors. And while there's a lot of different armor and sets of weapons to find, there's no randomization on stats or anything. It's not a loot game. You're only getting so much stuff, and it's a big relief. So most of your time, get this, is spent doing the actual fun parts of an RPG, fighting monsters and exploring the world. There's a lot to explore in this game, too. The world map is very, very large. It's full of little secrets and tons of unique little things, too. They clearly put a lot of effort into making this an enjoyable world just to be in. It's dense without resorting to covering the map in Ubisoft-style icons. So a lot of what you end up doing feels natural because you're the one who found it. You're not just marking objectives on a checklist. You're doing things because you want to do them. At least that's what I assume. Maybe there's something wrong with you. I don't know. But yeah, and there's tons of cool stuff to find. I haven't played a game that rewards your curiosity like this since Elden Ring. Like there's some really, really crazy stuff tucked away in the corners of this world. And yeah, while you're wandering around, you are going to deal with a pretty constant onslaught of enemies. Mostly some combination of wolves, goblins, bandits, harpies, with a random giant monster thrown in good measure like a cyclops or a griffin. The world is just dense with enemies and ambushes, so it can get a little exhausting after a while. I'm not gonna say it can't. It'd be a bigger issue if the combat wasn't so damn good. And make no mistake, it's very good. No matter whether you're playing as a warrior, an archer, a thief, a mage, or one of the more exotic hybrid classes, you're gonna have a ton of tools to work with. Every class has a few basic attacks, but the many special moves you can unlock really change how your character works. As you rank up your class, you unlock flashier and more over-the-top abilities, and it really works well. One important thing to keep in mind is that if there's one thing this game isn't, it's Dark Souls. There's no dodge button by default and no lock-on, so how you end up playing is pretty fundamentally different. You can climb on top of monsters to stab them or grab their legs and push them over. Everything's fully affected by physics, which can sometimes work out in your favor and sometimes really work against you. Battles can be chaotic and crazy. The terrain you're fighting on can make a huge difference in battle. As you explore and fight monsters, your overall health slowly drains from scratch damage, and the only way to heal it is to rest in an inn or make camp. The addition of camping also makes Dragon's Dogma 2 an obvious pick over the original. You're no longer forced to wander around in the pitch black night, and it doesn't just restore your health without having to take a lengthy trip back to town for an inn. It does other stuff. You got the prerequisite cooking menu, only this time you're cooking real meat. It's such an odd but charming inclusion to make all the cooking cutscenes full motion video, like actual video footage of cooking of meat. It's another way this game is doing its own thing. And there's a lot of combat because there is a lot of wandering around. There's very few options for fast travel. There are ox carts, which can transport you between major cities, and it's a very rare, expensive stones that can be used to instantly teleport, but that's it. Which means you're going to be doing a lot of hiking, which would be worse, but the world is, it's honestly so beautiful to explore, and the combat is so enjoyable. Having to walk through certain parts multiple times doesn't quite have the sting it does in certain other games. This is a stunning game at times, too. The environments are incredibly detailed overall, and at any given moment, you'll be at a grand vista that's hard not to just stop and stare at for a while. I'm playing it on PS5, and while the visuals are excellent for the console, the frame rate isn't quite there. If you're on the wilderness, it mostly stays above 30, but in certain dense areas like the main city, the frame rate's going to tank. I wish the game had some kind of performance mode to make up for this, but it doesn't. If you want 60 frames per second, Dragon's Dogma 2, it's not going to be on console. That's not happening. That's not how you're going to get it. You got to get it on PC. But I'll also say that the 30 frames per second didn't really bother me. Didn't hurt the experience of playing it. At the very least, the performance is a lot better than the original game on Xbox 360. Now that was a chugger. As someone who's usually pretty sensitive about games that aren't 60 frames per second, this one really wasn't so bad. It might be that I've played the original a lot, and this feels a lot like the original, except for it doesn't crap out the way that the original did all the time. And like there's some games that target 30 frames per second that feel like they're in slow motion or underwater. This game feels really responsive at that frame rate, so it's pretty tolerable, at least to me. I haven't seen any bugs. Like, I don't love that frame rate, but man, not one bug so far. That's for how complex this game is. I've definitely seen a lot of oddness, like certain enemies barely hanging off a ledge, or NPCs shuffling into place, or awkwardly facing the wrong direction to talk during a quest or something, but that doesn't mean it's not working right. That's just a little bit of that jank. I kind of expected that. Bugs and jank are different things. And there were parts of the game where I thought maybe like a trigger was missing, maybe a real bug, but wrong. That was just me being dumb. I'm just so used to RPGs handholding you through quests that when a game makes me figure it out, it feels wrong, which I guess is kind of really sad, actually. But it makes me really happy that this game trusts me. I don't know. There's something about that makes me like it more, even though it might be a little bit more frustrating. I do think that is going to cause some people not necessarily to jive with the game. It does expect a lot out of you. Like I said, I like that, but not everybody is going to. Many things are they're not explained, or just expect you to experiment to figure it out. And the actual main plot isn't super interesting, at least at first. It eventually goes to some pretty wild places, but the first dozen or so hours, there's not a really large amount of attempt of getting you invested. It's one of those games that's so confident in what it is that it doesn't even try to rope in new players. And to me, it's so good. The lack of tutorials, the straightforward opening, the unmarked secrets, open-ended quests, it expects a lot from the player. It trusts the player to be able to do those things. And if you're willing to go with it, there's a whole lot of fun to be had here. They did not dumb it down to capture a wider audience. It's a game that's unlike almost every other open world game out there. And while there are some boring and awkward moments, it's overall a game that I would highly recommend to anybody who loved the original or wants an open world game that's a little less formulaic than we normally get. It's frustrating and it is confusing at times, but it's the good kind of frustrating and confusing. The kind that keeps you coming back for more because when you figure it out, you're like, thank you, Capcom, for letting me do it. I did it. Thank you. It's an excellent game overall. But what the hell's going on with the generic fantasy music over the title screen? What the hell is that? I don't understand that. Maybe you do. Leave a comment. If you like this video, click like. If you're not subscribed, now's a great time to do so. We upload brand new videos every day of the week. Best way to see them first is, of course, a subscription. So click subscribe. Don't forget to enable notifications. And as always, thank you very much for watching this video.
Rise of the Ronin came out already?
And we're back with another episode of Before You Buy. That show will give you some straight up gameplay and our first impressions of the latest games releasing. As usual, it's me, Jake Baldino, and today we're talking about...
Yeah, I don't know. Dragon's Dogma 2 actually looks pretty interesting. Seems like an interesting game. I'm not gonna lie. Why the fuck does his...
Am I wrong?
Game look so shit, though?
Yeah, you can have 3 pawns. 2 mages, though, in the team. That's just what we fucking need. Let's go, baby!
It will be an honor to serve by your side.
The honor's all mine, Allura.
Like, this looks horrible.
Now, your first role on the squad is to sit here and wait while I take a shit. I'll be right back. Give me 2 seconds.
Yeah, Dragon's Dogma 2 actually looks
Rise of the Ronin. This is the newest game from Team Ninja, the folks behind so many games. More recently, Neo 1 and 2, and Wolong Fallen Dynasty. They've kind of taken things they've learned from those games and set their ambitions on an open world adventure in a cool historic setting. And while Rise of the Ronin is definitely almost clearly flawed, so far I've been having a lot of fun with this one. There's a lot to it, a lot to explain and break down. So before we do get into it, just the usual disclaimers. We've been playing a review copy.
It doesn't look unique. Like, I think Dragon's Dogma 2 actually looks pretty unique. Ooh, low ratings.
And we're back with another episode of Before You Buy. That show will give you some straight up gameplay and our first impressions of the latest games releasing. As usual, it's me, Jake Baldino, and today we're talking about Rise of the Ronin.
Dragon's Dogma has a lot of features that make it great, but the best part by far is picking things up? Well, yeah, you can pick stuff up and throw it, but you can also do it to people. Walk around and pick up whoever you want and throw them into the dirt. Even throw your trusted pawns, although they do take some damage, so be careful how high up you try this.
Jesus
It's
Christ.
something simple, but it's awesome. You can grab a guard and walk around with them. They might not be happy about it, but hey, that's tough. Dragon's Dogma has a lot of features that make it great, but the
Let's look at the review of the game.
In a way, Dragon's Dogma 2 reminds me of Sam Raimi's Evil Dead 2, which was more of a remake of his first cult classic comedy horror movie than a sequel.
Oh, wait, yeah, actually, I did see this.
To really dial in his true vision for Ash's Bad Night with the Bad Book.
Bro, watch my friend's house.
Dragon's Dogma 2 doesn't stray too far from the blueprint that turned it into a cult classic of its own over the past decade, keeping its second-to-none action design and vague but robust and alluring world as its centerpieces. Like the 2012 original, it is unforgiving out of the gate thanks to brutal enemies and chaotic encounters that are not designed to gradually ease you in.
So one factor here I want to mention is that I am going to play this game on the hardest difficulty. Is there a hard mode in the game like there is in the first game? No, there is no difficulty. Thank God.
It's also
just a
high
base
levels
game.
of janky. All of its systems seem precariously fitted together with the fragility of a well-pruned Jenga tower. Yet, remarkably, it never falls over. And its open-ended design allows for a barely controlled chaos that makes some of its inconveniences
Man, bro,
almost
this guy's
feel
one
intentional.
savage.
Almost.
That don't make any fucking sense, bro. Like, Medusa was supposed to petrify you if you looked at her. They weren't even looking at her and they can get petrified? How's that work? Huh?
New dark
This is 0 out of 10, bro. This game's unplayable.
To wander down
Bad game.
These things will never make themselves known to you if you don't go out of your way to look for them.
Well done, Rosamund.
Early on, simply walking from quest point to quest point through the verdant forest or dusty crags is a huge risk, as the wilds of Dragon's Dogma 2 are filled with creatures who would love to make you lunch.
It's a cop goblin.
While lots of open world games with day-night cycles stress the dangers of venturing out when the moon is high, I don't know of any other game that has a more brutal night than this one.
Valheim nighttime can be kind of bad.
Wake up! The explicit lack of waypoints and map markers for the side stories really helps nail the feeling that you aren't simply a walking task bot for the world's NPCs to wind you up, but a curious member of a living, breathing place that will march on valiantly whether you find what you're looking for or not. You'll be doing lots of backtracking and exploring on foot, as there's very little way of convenient fast travel. In the first few hours, having any squabble evolved into a rolling melee with every other beast within a square mile became annoyingly commonplace.
The ogre, or the cyclops, these things are bigger than they were in the first game. These are way bigger.
Skirmishing goblins trying to keep their distance from you and harass you at range.
Same with these are way fucking bigger, like twice the size.
Smosh through the combat, and in turn, this attracts the eye of a griffin to dive bomb the encounter like a feathery wrecking ball.
The following video is fairly long. There are links in the description below so that you can watch pieces of it at a time instead of committing to the whole thing. I did this way instead of forcing people to watch multiple videos on the same game. So let's get all the usual details out of the way first. Dragon's Dogma is an open world action. So why play games? What sort of experience are you hoping to have? What main quality do you look for that makes you like a game or multiplayer? The heart of any competition is fairness and balance, or else what's the point of it? If you're playing a shooter and your team has guns that deal less damage than your opponent's team, then it's not really something that's worthy of your full attention. Yet that doesn't stop a lot of games from smashing these two together, with some having more extreme takes than others. Progression systems are, in my opinion, an epidemic in modern gaming, but they can still work well. I'm playing Stardew Valley right now and loving it, and that game is one big tangled mess of progression loops. But my fear is always that these steady drips of experience points and game skill levels and the like will stop being complementary parts of games, and instead that illusion of mastering a system will end up replacing it. It's very difficult to have a skill-based game that allows you, the player, to level up outside of the game while also letting you, the character, level up inside of it. Dragon's Dogma is a progression game disguised as a skill-based one, and has two big instances of what I think is unintentional deception. The first being that the open world map is a hell of a lot smaller than you'd think upon first seeing it, and that its deep player-driven combat system is nothing of the sort, and is almost purely determined by stats, grinding, and gear than anything else. This appearance of a skill-based system is so strong that you'll often find people defending the game on discussion forums, fans that are insistent that the game's all about skill, to the point that some compare it to Dark Souls. I've even seen the same get good mantra said about the game. So already I think many who have played the game might disagree with what I just said, so let me go through it all while also explaining how my first few hours of the game went, and how I didn't fully grasp how reliant the game is on gear and grinding until I was deep into hard mode. Also, I just want to reiterate real quick that progression-based games aren't inherently bad, but it's a difficult mix to pull off with an action RPG, rather than just a plain old vanilla one. Combat encounters are split into two types, big bosses or hordes of fodder. Sometimes they mix and you have to clear some smaller enemies while a bigger one stomps about. Smaller enemies aren't really that interesting and tend to die quickly. It's the larger ones that make the game unique. You can't directly control your pawn. You can shout suggestions, but you have better luck teaching a baby calculus. The options on your own character are the primary way you'll be going through encounters, and you're also heavily limited here, but it depends on your vocation. In general, you'll always have light and heavy attacks and your jump. These cost 0 stamina and can be spammed. Then you have special attacks which you select by holding down the triggers on your controller. So your face buttons will change from light and heavy attacks, the special ones that you choose and assign from a list that you unlock while you gain vocation levels. Things like a rapid charge or a sidestep swipe. Both skills and magic work in a similar way. The system is initially awkward since you have to learn how the buttons are modified by holding down the triggers, but I like it now that I'm used to it. It's similar to other games, there's always a learning period for controls, and in this case it pays off and feels natural by the end. The flow to battles goes like this then. Spend your stamina on special attacks, and then spam regular ones while your stamina refills. Very slowly. Climbing also drains your stamina, so you have to choose what to spend it on and when to go into spam mode to let it refill. This may all sound good. There are options, right? Variety too, with different skills that you can choose yourself. But if you're after a player skill-based, challenging system, then all of this is ketchup and mustard slathered onto hide a rotten burger. And here are the 3 reasons for that. But whoever that might end up being. You're given a choice like each arisen before you, to sacrifice your beloved dragon or to try and kill him yourself. If you make the sacrifice, he'll fly away and let you lie to everyone that you were successful in killing him. If you stand against him, he promises that he'll kill you and your beloved anyway. I don't think this is a real choice. Most players came here for a boss fight. There's no real hesitation here. You want to fight the dragon. And if the rest of the story was told well, with some developed characters and a coherent plot, then this twist could be cool, since it's made clear that the past arisen in the world took the dragon's bargain. It's why the Duke goes mad and tries to choke his wife in that scene. It's one of the better ways to have a twist.
In a way, Dragon's Dogma 2 reminds me of Sam Raimi's Evil Dead 2, which was more of a remake of his first cult classic comedy horror movie than and camera with a habit of going haywire at the worst times are all features I wish hadn't been brought back for another round. Even so, there's an action RPG here that is richly rewarding and incomparable to its contemporaries if you can be patient with its quirks and open to embracing its hands-off open world and quest designs. For more on the technical side, check out our full performance review of Dragon's Dogma 2. Or for an action alternative, our review of Outcast: A New Beginning. And for everything else, stick with IG. Your personal NPC sidekick whose purpose is to assist you on your journey. Pawns are invaluable because they can take on a class, which Dragon's organize the party's inventory, or even craft on their own, which means they can add so much more value this time around.
I'd gladly see you put what I find to good use.
Pawns can even be sent off to join other players.
The game seems unique and interesting. That's what I'm looking for. I'm looking for a unique and interesting game to play. But yeah, I do have I got Metal Gear Solid 2 and 3 to go through. Resident Evil 4. Final Fantasy 16. The Last of Us Part 2. Yeah, I got some games to finish. God damn. At some point, you just gotta take an L. Now I see why people like sell their games. And they're just like, dude, I just gotta take the L on it. I can't finish it. Oh, I gotta finish Cyberpunk as well. Oh, fuck. The Nier series. Oh my god, I have a lot of games to finish. Damn. Okay. Anyways. Enough about that. Let's get into this. So we got to review homeworks, and then we're pretty much done, I think. Let me go use the bathroom real quick. Fill this up with more water as well. Okie dokie. Let's go through this now. Hyman Fellman. Okay, listen. We're gonna have to be smart with what we go through, okay? Hyman Fellman, we know how to do this. Skip this. Energy shift due to finite nuclear size. I don't know. I don't even know what the fuck this is. Skip it. 3 and 4, these are the real problems. Okay, so let's go to 3 and 4. All right. Huh. This is the variational thing. First of all, let's go to the textbook. Let's refresh ourselves. What is the variational method? What is this again? What is this? I know we have WKB, variational principle. Here it is. Variational principle gives you a least upper bound on your state. Okay. Okay. Okay, I'm pretty sure I did this one correctly, I think. Right, yeah. Yeah, I got the same answer. Okay. Okay. Yeah. Why do we normalize? Oh, I guess because we need to figure out what n is. Okay, so n is a normalization constant, c is an unknown parameter. We want to solve for c by minimizing the ground state energy of the states. So there's variational principles, so some kinetic, some potential term. Yeah. Let me know this. Okay, I don't think we're actually gonna have to fucking do the variational principle. Dude, what the fuck? What the fuck? What the fuck is this shit, bro? What the fuck is this? Dude, what the fuck? Whatever, dude. Whatever, dude. Whatever, dude. That shit is fucking whack, bro. That shit is whack. Shit is whack. Anyway. Whatever, dude. I'm getting live updates. I'm getting live updates. They're the biggest live updates, and it's not looking good. It's not looking good, folks. Folks, it's not looking good. Okay? That's all I'm gonna say. Yeah, okay. Variation on the hydrogen. How do you do this? You normalize it so you can find what n is. Yes, yes, yes. Is this on the equation sheet? It's probably not. Why would I expect it to be on the equation sheet? It's probably not on the equation sheet, okay? It's probably not. Why would I expect it to be on the equation sheet? It's not on the equation sheet. No, it's not. Of course it's not on the equation sheet. That's okay. That's okay. It's not on the equation sheet. Making the practice for the midterm a homework assignment that is graded, and so you can't give out the solutions before the midterm is the stupidest fucking thing in the world. I don't know who. Like, it sounds like a good idea before you think about it for more than 5 seconds. And then it's like, oh, this is actually not a good idea. Oh, maybe I shouldn't make the only thing to prepare for this exam something that you won't figure out the right answer for. Maybe I shouldn't do that. Fuck everything, dude.
Post-vaccines take 3. Post-vaccines take 3. Post-vaccines take 3. Post-vaccines take 3. Post-vaccines take.
Oh, the instrumental for that is actually pretty good.
And it's so.
Oh yeah, baby. Anyways, number 3, variation on the harmonic oscillator. But yeah, basically you find the normalization constant so that then you can find out what C is, and the way you find out what C is by figuring out the Hamiltonian, the expectation for the Hamiltonian, right? It'll be in terms of these garbage things. We'll find you, look at the moon, maybe soon in a year or two, you'll find you. Yeah, I don't know. Okay, that's that. WKB approximations. This is quite important to have. Find the WKB spectrum for f of x equals kappa x. Kappa x. Look at the moon, maybe soon in a year or two you'll find you. Whoa, whoa. All that I can say to you is what I do when you like away for another day. Mario Judah absolutely popped with that song, okay? He popped with that. And the Playboy Cardi leak for it? It's even better, dude. I don't like this intro, though. It's kind of like lame, whatever. Like, the leak for this will never surpass the actual song. I mean, the actual song will never surpass this leak. Like, the leak for this is so good, man. So good, man. All it needs is the Mario Judah saying, I miss the rage. Mob Psycho is also such a good song. he took out way too much of the low end, dude. It sounds like a fucking telephone. He just oh sorry, he took out all the mid. He just took out all the mids to make it clean.
Man, where the fuck is my...
Shit is so good, dude. Honest to God, all it takes is just one song to define an artist. It takes one song and that's it. And it defines the artist. And for Mario Judah, that is a definitely Mr. H. Yes. Okay, yeah. Find the WKB spectrum. What you do is you just set this up, right? And then you do the integral by doing a U sub. You do a U sub. U sub. I guess you don't have to. Wait, for real? Why did I not know this? Why have I never known this? What? Oh my god. This fucking website, dude. Anyways.
Hey guys, square root of a term lets us tackle the minus 2x by the new indice. Half plus 1 is 3 on 2. And then we divide by the new indice. So divide by 3 on 2. And if you guys remember from the chain rule, we also have to multiply the function by the derivative of the inside function. So in this case, instead of multiplying, we divide. So the derivative of 1 minus 2x is negative 2. So we divide by negative 2. Plus the constant. So
why have I never learned this? What the fuck?
Hey guys, the aim of this video is to show
I've
you
never
the
learned
steps on
this.
how to integrate the square root of 1
I
minus
thought it was
2x.
U sub.
So our first step is to transform this integral into a form we're more familiar with. We know that a square root of a term is the same thing as raising it to the power of 1/2. So let's do that. dx. Putting it in this form lets us tackle the integral using the reverse of the chain rule to integrate. So from the chain rule, we have the function stays the same, 1 minus 2x. We add 1 to the indice, so we have half plus 1 is 3 on 2. And then we divide by the new indice, so divide by 3 on 2. And if you guys remember from the chain rule, we also have to multiply the function.
What the fuck? Why am I just now hearing about this?
The derivative of 2. Write this out, we get 1 minus plus the constant. Multiply the function by the derivative of the inside function. So in this case, instead of multiplying, we divide. So the derivative of 1 minus 2x is negative 2, so we divide by negative 2 plus the constant. If we simplify this out, we get 1 minus 2x to the power.
Why did I never
3 on
know
2.
about this? It's kind
Two
of
cancel
crazy.
out on 1, so left with -3. So this is the same thing as -1 on 3 plus C. And this over here is the answer to your integral.
Okay, yeah. That definitely gives that. Hold up. Let me cook, let me cook, let me cook, let me cook. Let me cook real quick, okay? Okay, I'm gonna cook. Okay, I'm gonna cook. Okay. Haha, boom, boom, boom. I just finished another part to a thing. Why am I still live streaming this? I do not know. Don't ask me. Hello, fair stranger. Do not ask me why I'm still live streaming this. For I still do not actually know why I am live streaming this. However, fair stranger, when I'm finished this. Bro, I need to take a shower, but I don't want to, bro. You ever feel that way? Hey, where's all my degenerate gamers at? You ever feel like, man, I need to take a shower, but I don't want to, but I know I'm dirty? Okay, I've been sweating up a anxious storm. Sweating in this room. This hot box of stench. Ugh, fuck. Fuck it, though. Fuck it, though. Okay. You know what, guys? It is what it is, you know? It is what it is, you know? You know, it is what it is, guys. I'm starting to get that. I was feeling tired, but now I'm starting to get that second wind that you get. Where it's like, oh, I'm energetic now. But you know what? It is what it is. It is what it is. Does the crown state energy have degeneracy? There could be no degeneracies. There's non-degenerate perturbation theory. I don't know what I'm doing here. I don't know what I'm doing here. I don't know what I'm doing here. Fuck it. I don't know what I'm doing. Okay. I'm just gonna turn this shit in. Shit is about to just be turned in. Okay. I'm about to just turn it in. Okay. About to turn this shit in. Call it a day. Okay, we're not pulling an all-nighter like I thought. But basically, me being up at 11:20, it's kind of an all-nighter. If you ask me, it's kind of an all-nighter. For me, it's an all-nighter, okay? I don't usually be staying up this late, okay? It's not allowing me to fucking select a goddamn PDF. Let me select my PDF, bro. Oh, just let me select a PDF, bro. Oh my god. Oh my god. Yes, make me authenticate on my phone. Send me an authentication. Just let me in, okay. Okay, so it is a Google Chrome problem. Okay, at least I turned that in on time, I guess. Submit. Just submit it. Just fucking submit the fucking shit, dude. Just submit the fucking shit. I hope he does something where it's like, well, you know, like, because you all fucking failed this midterm, or because a few people really did fail it, I'll just give you full credits on this one to give you extra credit. And yeah, to give you extra credit, bud. To give you extra credit. To give you extra credit, okay? I'll give you extra credit. Okay, so I know how to do the Heinemann-Fellman technique thing. The time-dependent perturbation. Fucking fuck you. I'm gonna get that all wrong. I know I'm gonna get it all wrong, and that's okay. Because I'll get it all wrong, and I'll be proud, okay? So there's gonna be that. I hope to God there's a Feynman-Hellman problem there, okay? Some Feynman-Hellman problem, okay? And then there's probably gonna be some square well or harmonic oscillator problem. It's probably gonna be a square well or harmonic oscillator problem, okay, folks? Okay, folks. Anyway, I'm gonna fucking fail. I'm gonna fucking fail my exam tomorrow. That's okay, folks. Folks, it's okay, okay? This won't be our first time failing, okay, folks? We've always made it back. We will just come back bigger and harder and even greater for the final, okay, folks? Okay? We're just gonna bet all of our marbles onto the final, okay, folks? That's what we do. That's how we do it here in America, okay, folks? In America, what we do, we go big or go home, okay, folks? So, I'm going to fucking fail this final. Don't worry, folks. I will fail it. I can guarantee you that, okay? I can guarantee you that I will at least be failing it, but But, we will come back on the final, bigger and better, badder than ever, okay? There will be 2-hour study sessions mandatory every day, every single day, okay, folks? 2-hour study session every single day, folks, okay? Mandatory, deep session, includes homeworks, okay? Because homeworks are study sessions, okay, folks? But yes, we're gonna be reading the textbook, we're gonna be reading the lecture notes. In terms of quantum mechanics, though, I don't know. Because the way that this professor teaches, it makes me want to fucking shoot myself off a bridge in Minecraft, folks. It makes me want to log onto my Minecraft server and fucking download a gun mod in Minecraft and fucking shoot my Minecraft character in the head with a double-barreled shotgun as many times as I can, folks. Okay. I'm gonna shower now. Okay. Fuck you. Whatever. It's whatever. It's done. What's done is done. Bye, guys. Positive attitude. Posy vibes only. Bye, guys.